including having to complete the helicopter development during a global pandemic. They had to get the size and weight of the helicopter down so they could achieve, lift using rotary blades in a very thin atmosphere. And then of course they had another late challenge with having to do a software change and update, and do that with a helicopter 180 million miles from Earth. So just an amazing job. This really is a Wright Brothers moment. It's the start of a whole new kind of
Wright Brothers
exploration, and we'll build on Ingenuity's success to see how we can deploy this capability on future Mars missions. We have this evolution of exploring planets in the solar system. First we do a flyby, then we'll do an orbiter mission, then we'll do a lander mission, then we'll land a rover, and now we've added another evolutional capability there, flight on another planet. Ingenuity was a technology demonstration, an experimental mission, but its success is truly remarkable, and it gives us this new capability. I believe, along with Mike and Thomas, that we should be doing these types of technology demonstrations on all our science missions to take advantage of the ability to prove out new technologies and capabilities that will then feed forward to even more ambitious and productive missions in the future. So you all have exemplified what it means to be part of this amazing NASA team. Many organizations, and you came up with this dream and this innovative idea, and you overcame all the challenges and made it happen. This could not be more proud of the team.
There is, Duber. The footage will be coming in a second.
In the global pandemic, launching Perseverance, landing Perseverance, and now deploying and flying the helicopter.
They did a helicopter on Mars.
Just incredible, and congratulations again. You all really personify the motto of Dare Mighty Things, and embody our nation's
helicopter
spirit
Mars,
of persevering even in the most challenging situation. And you are providing inspiration and advancing science and exploration for not only the United States, but for the world. So congratulations again. And with that, I'd like to hand it over to Mike Watkins.
Watkins.
Okay, thank you, Steve. It has been a great day here at JPL, and we're very proud that we are continuing to be at the forefront of daring mighty things in planetary exploration. And I wanted to build on something that you noted, which is that Ingenuity is a technology demonstration, right? It builds for the future. And in many ways, it is a perfect example of how we need to be doing technology and how we need to develop technology. And the brilliant engineers, some of whom you'll see in the orange shirts, came up with the idea for Ingenuity, for a Mars helicopter, before we had a name Ingenuity, over 7 years ago. And there was a push from technology, but it wasn't quite clear at that time. Was it really the right instrument?
Right now.
Was it really the
Leave me alone.
thing, a helicopter, to put on the Perseverance?
Right, Vanguard?
Rover. And so we did what we felt was right, which was we stuck to it, and we kept working on the Mars helicopter. We kept overcoming technological hurdles, and we kept showing why it would be valuable as a scientific instrument in the future. And a combination of rugged support from JPL in terms of technology development, as well as NASA headquarters, and an exceptional team that overcame all the technological challenges one by one, until it became obvious that
great
the
day
right
for the
thing to
space
do
community.
was to put it
Absolutely.
on Perseverance and fly it to Mars as a full demonstration. And I think that's the kind of partnership, the kind of push of technology and pull of science that we are now seeing to be very productive within NASA. And actually, we're working on several other missions that have technology components, much like Ingenuity, but going to other parts of the solar system as well. Now, our brilliant team has overcome a number of challenges. And for those of you that remember, back in 1997, we had a mission called Mars Pathfinder.
Oh, I remember.
And effectively a technology demo called the Sojourner rover. And that freed us up from being in the place we stuck the landing to being able to drive around. And now of course, those rovers have become Curiosity and our latest Perseverance, capable of driving tens of miles on the surface and going to the best places for scientific discovery. Well, what the Ingenuity team has done is given us the third dimension. They've freed us from the surface now forever in planetary exploration so that we can now make a combination, of course, of driving on the surface and sampling the surface and doing reconnaissance and even scientific experimentation on inaccessible places for a rover. And I think this is exactly the way we build the future. And I think you'll hear a lot more about the scientific promise of rotorcraft on Mars as part and other planets as part of the Science Mission Directorate portfolio. And to talk about the importance of Ingenuity and some of the future, I'd like to turn over to my colleague, Dr. Thomas Zurbuchen, who is the Associate Administrator for the Science Mission Directorate at NASA headquarters. Thomas.
Thank you very much,
Thanks
Mike.
so much, Mike. And I just want to tell you, as I'm starting here, I'm just so proud to be up here next to Mimi, especially that team here also on the monitor. And I just want to tell you on behalf of all of us at NASA Science how proud we are of you and how we recognize how important you are for this particular success. So
am I on the team?
One more time,
yeah,
everybody, to join me.
I'm very excited and very proud of
the
all
story of this team is compelling. It's a story of a great, perhaps even a crazy idea initially. Many people, have a really hard time. It turns out we all have a hard time, finding that right line between crazy and innovative. It turns out we're often wrong with that line. A crazy idea that was being developed, and this team put that idea into reality. The most important thing that takes, of course, is hope.
I'm not, Thomas.
It's the hope that that is actually possible to come together with with everything this team has, with the personal education, with the commitment to success, and with learning from each other until it actually works. So for me, what I want to point to is the first picture here, and I want to just tell you, this picture means two things for me. On the one hand, I recognize that this picture was taken from the Van Zyl overlook. And my friend Jacob is no longer with me. I see in this picture because I know that he was an important part of making this helicopter happen. The second thing that is important in this picture is what you don't know right now as you look at it. It's actually the after flight picture.
Wow.
And so it landed there, and it landed on the surface after this flight, and it did so safely. And so for me, again, what I see in this is now not only this amazing little machine, but the team that actually achieved that. And it relates this to a story that's 117 years apart and 173 million miles apart, a story that actually started even earlier with a little toy that a father brought home to two kids. They were about 10 years old. It's a rubber band with a little rotor. It's a little toy that never got out of their mind. They became bicycle mechanics, and they started working on this, and actually did that famous record in 1903 when they achieved first control flight on this.
Well, it looks good.
So when we look at the previous picture that I just showed, I want to just tell you that in homage of this amazing achievement, we have designated, and please pull up the next picture, have designated this landing site as the Wright Brothers Field.
Cool.
We are so excited to have these two stories, the story
That's not the Wright
of
flyer.
Ingenuity and their team related to the Wright brothers. And I just want to tell you, as we go forward, actually, that connection has already been made, and we talk about it. I have here in front of me a little sample of the flyer, actually the actual fabric that did that historic act in 1903. And what I want to show you in the next
because you can say it's the wrong flyer,
is actually how this sample, you see there's a piece missing in what I just showed you. In the next movie, I show how this piece that is missing was actually included on this flyer, and this morning made history together with it. So,
that's cool.
So for me, Mimi team, Ingenuity team, history connecting those two amazing stories together has been made this morning. And why don't you tell us more, Mimi Young, about it?
Right, thank you, Thomas. Well, our team has been working over 6 years, some even longer, towards that dream of experimenting the first ever flight at Mars, and this morning, our dream came true. If we can play this video, this is taken from Perseverance rover, video of our dream, just beautiful.
Bro.
Goosebumps. It looks just the way we had tested in our test chamber, space simulation.
Dude, it turned.
Simulator chamber
I didn't notice
here.
that before.
Absolutely
It rotated
beautiful
90
flight.
degrees.
I don't think I can ever stop watching it over and over again. And lands. Well,
I love it.
when things work,
They did helicopter on Mars.
I would like to take this opportunity to remind how difficult it is to fly a rotorcraft at Mars. First and foremost, because the atmosphere there is so thin, right? About 1% compared to that at Earth. That's like on Earth being elevation 3 times the height of Himalayas. So the air is very thin, and Ingenuity had to be really light, small, and has to be able to fly in this thin atmosphere and survive on its own. It did all of that
So ridiculous.
under 4 pounds. So Bob Belram will be talking more of that, but I did want to remind that. Well, this morning was an incredible moment. Our team reaction here this morning, this video.
They did, Corey.
It was around 3:30 a.m. this morning,
Yeah,
but it
6:30 in
sure
the
didn't
morning.
feel like early in the morning. It just felt like a very normal middle of the day.
Pretty much HPV, right?
Extraordinarily exciting.
Data products confirming that we unpacked image and 1 Hz data. This is downlink handing off to flight control for telemetry analysis.
Swash plate servos appear healthy. Overall actuators appear healthy.
This flight control confirming that we have EVRs from Ingenuity. Ingenuity is reporting having performed spin-up, takeoff, climb,
Yeah, I know,
Hover.
Crash. It's pretty insane.
descent, landing, touchdown, and spin down. And altimeter data confirms that Ingenuity has performed its first flight, the first flight of a powered aircraft on another planet.
You gotta be kidding me. Well, that's something you don't see every day.
It's unforgettable day, unforgettable day. And you know, it's all about the team to start with. Really, you know, our team across JPL, Ames, Langley, with our industrial partners, AeroVironment.
I heard some of the news from Mars today.
Qualcomm,
What did they do?
Lockheed, others.
They did a
We
helicopter
were a team.
on
I
Mars.
mean, just a strong team. And during this morning downlink, I did say that we had many friends who contributed to our success, okay, and including Perseverance rover team and many, many others. And some of them are far away now. And again, as Thomas mentioned,
This is so legit, dude.
Jacob Van Zyl, I'm sure you were watching our first flight from the Jacob Overlook. So we're thinking about you, David. I'm thinking about you, Jacob. So with that,
David too. What
this
about
early
David,
morning,
Mimi? Come on.
Flight, what it means for our mission success.
screw David.
Mars Helicopter Ingenuity Technology Demonstration Project has 3 goals in line with
David's not right
NASA's
here.
agency level
Nah,
objectives.
screw Jacob.
So
David's
the
the
first
real MVP.
is
Okay?
to show
I don't know who either of
on
these
Earth
people are.
that it is possible to fly power control flight at Mars. We did that before we were launched.
I don't think people realize
And
how
then
big of a
the
deal that
second
is.
goal was
It's
to
pretty
actually
cool.
fly at Mars. We have done it.
They
This
did
is
a helicopter
the
on
first
Mars!
time we've done it. And the third goal is to get data back that will inform engineers that are going to designing future generations of Mars helicopters. And we have done that too, and we're going to continue. So beyond this first flight, over the next coming days, we have up to 4 flights planned, and increasingly difficult flights, challenging flights, and we are going to continually push all the way to the limit of this rotorcraft. We really want to push the rotorcraft flights to the limit and really learn and get information back from that. So with that, I'd like to hand over to Bob Bellerin, our chief engineer and really the innovator of our original design for Mars helicopter. Over to you,
Push
Bob.
it to the limit.
Thank you, Mimi. First, I'd like to just take a moment to thank all
Bob?
of you who have been on this journey with me. There's been many a technical
Thanks,
conversation, many a late night, many a test, and
I know.
want to thank all
That's
of you
pretty
who have
cool.
been part of that, and your families and your loved ones who have helped, get us
Helicopter
to this point.
on Mars.
Ingenuity itself is extremely healthy at this point. In fact, she's even
No
healthier
Chris.
than she was before this flight. She shook off some of her dust that had been covering her solar panel and is in fact producing even more solar energy than before.
Cool.
The batteries are looking good. The communication system is fantastic. The landing gear appears to have worked well. All the servo mechanisms and motors are doing great. The computers and the avionics behaved flawlessly. So all in all, it's in a perfect state, and I'm just really excited to see what all she can teach us over the next few weeks as we explore aerial mobility on Mars. And with that, Howard, if you can tell us about exactly what happened during this flight, that would be great. Thank you.
Yeah, this flight was all about proving that it is possible to fly on Mars. So to that end, what we had instructed Ingenuity to do was to climb to altitude of 3 meters,
10
hover
feet.
there for a little bit, about 5 seconds, then make a turn of about 96 degrees, hover for another 20 seconds, and then go to land again in the same place that it took off from.
Yeah, I got it, Chris. Thank you.
And that's what we told Ingenuity to do, and it did exactly
Savvy,
that, and it
wouldn't it
did
be
it
something?
just perfectly. From everything we've seen so far, it was a flawless flight. It was a gentle takeoff. At altitude, it gets pushed around a little bit by the winds, but it really just maintained station very well, and it stopped the landing right in the place where it was supposed to go.
Yeah, Zonko, it's pretty crazy.
When we were looking at the downlink data this morning, one of the first things, or one of the most important things that we were looking for was this plot that you can see, which is a plot of the altimeter.
Awesome.
That was really our first indication, or real
I
proof,
don't know what my bad.
I should say, that, yeah, we really did leave the ground. We really did fly. In addition to this
right.
kind of telemetry, during the flight itself, Ingenuity was telling us all along what it was doing. And so what we were able to do with that data is we could take that data and reconstruct the flight and create an animation out of it. So what we're going to see here is such a reconstruction where we've taken that engineering data and animated the flight accordingly. And what that allows us to do is it allows us to look at the flight in a different way, for example, from different angles, up close, and see kind of the small motions of the vehicle. And what you will see here is that it's just really, really steady. Just a beautiful flight.
Guys,
the
this is a
initial
reconstruction.
hover, and then a turn.
Bro.
And then hover again for 20 more seconds. And then the landing. And just the tiniest little bounce that you can see there on the landing. And that is also completely expected. I think we have a video as well from the rover that we looked at before that we're going to see again. And this again, shows us the same thing, this time with real images from the vantage point of the rover. And it shows you when you get up to altitude here, a little bit more clearly how it gets buffeted a little bit by the wind and how it very gently makes its way back and lands safely where it needs to be.
Dude.
And what's exciting about this is a flight that we've done hundreds, if not 1,000 times before, but always in simulation. It's always been on a computer.
That's crazy.
And to see it now finally happen on Mars and happen exactly the way that we imagine it is just a really incredible
I'm not sure,
feeling.
artist. Maybe they'll talk about it.
Now, while it was flying, it has to keep track of where it is. And the way that it does that
It's because it
in
knows where it
part
isn't.
by taking images of the ground below it, 30 images per second, and analyzing those
Wow.
in order to understand how
That's
it's
a
moving.
lot.
Now, those images are primarily there exactly for that purpose, not necessarily there to be looked at, but it turns out, we grabbed a few of those images and
1% of
downlinked them
Earth
to
here,
Earth
Bennis.
this morning, and it turns out they're absolutely stunning in what they show. What we see here is Ingenuity taking a picture of its own shadow right below it. And I think this is just a stunning image, notwithstanding the fact that it's, a low resolution.
Discovery, go and throttle up.
Chris,
black
give this
and
up to
white,
Bennis.
Photograph.
Well then.
We have another image from the same camera, which shows just a moment right before touchdown. You can see the legs are just about to meet the ground here. And this is a very interesting image to me, in part because of what it doesn't show, which
that's
is
cool.
it doesn't show a lot of obscuration from dust, which is one of the things that we weren't so sure about prior to doing this experiment. So already we're learning things here. And in particular here, dust did not seem to be an issue in terms of obscuring the navigation camera close to the ground. In the next few days, we expect to perform further flights, and we also expect to get color images down from the helicopter. Now,
It's crazy.
one more thing that I want to mention here is that the International Civil Aviation Organization has assigned us a 3-letter designator for Ingenuity, IGY, India Golf Yankee, with the call sign Ingenuity. And those details will be officially included in the next edition of ICAO's designators for aircraft operating agencies, aeronautical authorities,
That's
and
cool.
services.
That's
And the
very
location
cool.
of the flight was assigned an ICAO location designator, JZRO, for Jezero Crater, where the NASA Mars operation took place. And of course,
Dude, that's so legit.
these designators come in handy when we.
It's
go to
actually that means
write
it's
our log-
officially
in
an
our
airport.
logbook. This is something that should be
On another
very
planet.
familiar to any pilot out there. We always want to log our flights so we don't forget that we did them.
I want that.
And so for that purpose,
I want it.
we have, this. I have this logbook with me. It says the nominal pilot's logbook for planets and moons,
I want it.
because we're always thinking ahead here at NASA.
I want that.
So with that, I'd like to talk to Justin, who will talk more about the imaging.
Okay, thank you, Havard. I'm Justin Mackey. I'm the Perseverance rover imaging scientist and also the deputy PI of Mastcam Z. And I'm here just really happy to be here to share with you the results of our imaging
Yeah, let's
over
see.
the last few hours on Mars. There's sort of two cameras that we're talking about.
What's the tower? Is
video
Perseverance the
camera
tower?
is the Mastcam Z camera, which is a science camera that PI is Jim Bell at Arizona State University and his team over there, and it was built
Discovery,
by
go
mainland
and
Space
throttle up.
Science Systems down in
I
San
don't know,
Diego.
Billy.
Mike
You
Kaplinger,
die?
Mike Revine with the hardware group built an excellent piece of hardware for us, and also Jensen running the ops team down there, and Kim Saxon here at JPL as our instrument engineer, and a whole team of people made this happen. So I just want to thank all of them for getting us to this point. And then the other camera,
That's
I'll
cool,
show some pictures
Snackless.
from the ECAM system, the navigation cameras on the rover, with our ops team. Those cameras were built here at JPL, and our ops team, Nick Ruoff and Amy Culver. So just credit to the entire rover team. I'm wearing my rover blue here. I'm actually on the heli team also, but I had to pick a color, so I'm representing the rover team here. The uplink and downlink engineering teams, just keeping the rover running. The orbiters, our partners, getting us all this data is just really amazing, and we thank all of them, both here in NASA and ESA, TGO, and also the Deep Space Network. So I just wanted to thank all of these people for making this really happen. They enable all of this work. So with that, without further ado, I guess we'll go to the video one more time because we cannot see this enough. By the way, it only came down about 2 hours ago, the full frame. So let's go ahead and show the video. I'll talk a little bit about it. It's a 720p video. It's 1280 by 720 pixels. It runs at about 6.7 frames per second. And we originally had the strategy of downlinking the 2.4 second snippet. So there it goes. You can see it taking off. And if you look carefully, you can see it turning in flight. People have talked about that. And this is new. This just came down right before this press conference. Turning in flight and then coming back and landing. So I mentioned the frame rate. This is with our one of our wider angle settings on the camera, 34 millimeters. So it's a little more a contextual shot. We also shot a full zoomed version on the heli itself where the heli flies out of the field of view. We have not downlinked those full frame images yet.
Damn.
So we're expecting those in the coming days. We did verify from the imagery that the heli did take off about 3 meters above the surface.
10
so
feet.
That's an independent verification. The heli blades are a little blurred due to it's about a 10 millisecond exposure, which is about a 1/2 rotation of the blade at 2600 RPM, roughly, like 0.4.
It's one.
And let's see, and we've received
0.1
about
kilofeet.
14 or a little over 1,000 frames. I
0.1
counted 1,400
kilofeet.
last check, out of about 2,000. So once again, the orbiter performance has really made this possible to even show you this so quickly to get video from the surface of Mars. So it's really an amazing feat by everybody. So the next image then is, again, going back to the fully zoomed 110 millimeter.
Hey, I made the
Mastcam
measuring
Z.
system, guys. All right, 10
Picture
feet
of the
is
heli on the
0.1
ground.
kilofeet. I don't care about your
This is
names.
just
I don't care about your
nice
sense.
shot
All right,
showing-
it's not
if
supposed
you
to
look
make sense.
closely,
It's the
it
whole
may be
point of
hard to tell.
kilofeet.
If you look closely at the center, you can see that there's a camera on the helicopter itself that is now facing the rover, and it was not facing the rover before. So that's proof that it did turn in flight. And it's just a nice shot showing that the heli landed safely, and that's just a great picture to have. So then the next picture is now switching cameras. We're going to go to the NavCam camera, and the NavCam camera does not have the video capabilities like Mastcam Z, but we did take pictures during the flight, and this blink, hopefully it'll blink. You'll see the heli. That's the heli on the ground there, looking carefully. Okay, no, actually, you know what? This is the other one. Now, if you look carefully at the heli, you should be able to see it shifting. That shows the difference between the takeoff location and the landing location. Maybe hard to see in the video, but we'll put that out on the. We'll release that so people could look at that more closely. I can see it from here, but hopefully it'll come out on the video. So it just shows that the landing was just sort of real pinpoint landing there by the team, and so congrats to the heli team for just nailing it, Havard and company. And then the last video, or the last blink GIF shows, hopefully it shows the full height there.
He said
there
GIF.
Okay. So we have the full height of the helicopter there, captured by the NavCam mid-flight, and then a comparison with the heli then on the ground, which will show the full height. It's hard to see the video there from here, but the main summary is that we actually, you know what, I'm looking at this. This looks like this is the Mastcam Z again. Well, we just got the data all down, so it sounds like it might be slightly out of order. I think the main point here is that we are swimming in data right now,
Jindo.
and we're just cataloging it basically and learning about the flight. We're just extremely happy for this this whole team, the rover team and the heli team. And I just wanted to close my statements by mentioning. I mentioned that I was on the heli team. This is like with Bob, like 7 years ago, where we were talking about taking pictures from the heli.
Go at throttle up.
Seeing it all come together like this is really reminiscent of another project that I worked on 24 years ago, the Mars Pathfinder mission, where we had the Sojourner rover, which was a new technology, a new capability. there were skeptics at the beginning, and then once something like this happens on Mars, the skeptics get converted, and it soon becomes a new way of doing things. And I really feel this project, this team has the same vibe that we had 24 years ago with Sojourner.
Cool.
Just seeing going from a concept
Chris,
to
skip this up to
demonstration
Jindo.
like this is going to open up new avenues, new ways of exploring. So it's very exciting. We're very excited that this is all working so well, and just happy to get all this data back.
All right, thanks Justin, and thanks for rolling with it. As Justin says, the images are all coming down in a fire hose, and we will make the images available for you all online, so look for it on the website. So we're gonna transition now into Q&A. So a reminder for our colleagues from the media, if you're on the telecon line, please press *1 to get into the queue. And for others who are using social media, you can use the hashtag
gifted us up to Ancilla.
#MarsHelicopter.
Thank you.
Our first question on the media line comes from Marcia Dunn of the AP.
Yes, hi.
Discovery,
Congratulations.
go and throttle up.
I've got a couple questions for the chief pilot, I believe, Mr. Grip. What was the
Mr.
wind
Grip?
speed at Wright Brothers Field today for the flight? And when are you anticipating to attempt Flight 2? I know you had a schedule laid out in advance, but since you're a week down on the timeline, I wasn't sure if you were going to try to rush things along. Thank you.
Yeah, so in terms of the winds, we did take additional data during the flight, and we expect to get some more information about what the actual winds were at that time. What we can operate with is at this point is the forecast that we have based on prior data, and there is some uncertainty on that. But the most recent indications that I have is that it was on the order of somewhere between 2 to 6 meters per second of wind, and that's what we were dealing with. And that would seem, just eyeballing the behavior of the flights, that doesn't seem inconsistent with the behavior, although it's hard to say much more than that. As far as when we perform the next flight specifically, I'll let Mimi perhaps answer that question.
Sure, yeah. So we'll get the high rate data downlink from the helicopter to us tomorrow, and then we will be attempting to fly within the next
Dude,
few
Mimi's
days.
into
so we're
it.
targeting for
And I like that.
Thursday.
That's cool.
But we'll know more after we get the high rate data.
Mimi's all about that life.
Great, thank you. Our next caller is Kenneth Chang from the New York Times.
Hi, so I was wondering if you had better plans for the 4th and 5th flights. I guess when I talked to Mimi, Bob, and Hobart last year, you had mentioned aiming for 500 feet at 15 meters. And I was also wondering, when conceivably might there be a second helicopter on Mars?
So in terms of flights 4 and 5, I think we still have a little bit of team discussion, on basis of just today's
Discovery,
flight.
go
There's
and
also
throttle
that
up.
and what we're going to get over the next 2 flights, flights 2 and 3. And that will inform what we do for that. But in general terms, what we're talking about here is going higher, going further, going faster, stretching the capabilities of the helicopter in
Make
those
it.
ways.
Do
But exactly
it.
how far
Makes
in those
us.
directions is a discussion that we need to have.
More
So
than
regardless, I can
Power,
we will be pushing the envelope. So as we succeed in certain lateral flights, we're going to go further, faster.
They did
Definitely, especially towards the end of the experimental window,
on Mars.
we will be pushing the envelope and
What are you
really
typing? None of your
stretching and
business,
understanding
fool.
How well, we can fly.
Chris gifted us up to
So
LQ2
for the
NKSP
second
guy.
helicopter
Chris, you're
question,
going bananas.
I'll pass it to you, Thomas.
Yeah, and of course, I can.
Oh,
the
yes,
answer
thank
is
you
I
very
don't
much.
know, what the answer is.
We
When
don't
are
know
we gonna
what we're
fly?
going to do.
I mean, what I'm really interested
You playing
in is,
KSP?
frankly,
No.
the science community's ideas about how to turn this into a science machine. From a tech demo into a science machine, and you see what the opportunities are to fly to Mars. You know that we have something scheduled in 26, 28 with Mars sample return, but we do competitions on a regular basis for missions that go elsewhere. I mean, we're really interested now going forward, but there's nothing set right now into stone as to when the next helicopter will be going to Mars.
Okay, great, thank you. Our next caller is Bill Harwood of CBS News.
Bill Harwood, CBS News.
Are you there with us, Bill?
Bill? Bill?
Sorry, can you hear me now?
Yes, there you are.
Oh, sorry about that. This is a question for Mimi. You said in your blog
like
post,
Bill. Bill's all right.
the weekend that you guys had come up with this software fix, and you warned us that there was maybe a 15% chance it wasn't going to work. You didn't know for sure, and that if it didn't, you just would try again. What is the strategy going forward, given the results today? Is that what you would do on flights 2, 3, or 4 if one of them gets delayed by this software problem? You would just try again. And I'm wondering, is there a deadline where the Perseverance folks really want you to be finished so they can go on with their mission? I'm trying to wonder.
Bill always has really good questions, man.
Thanks.
Always.
Absolutely. So
never
this,
fails.
Command only option that we chose, the simpler option, it has paid off. We got our first flight in hand, and for the second flight, we will be using the same technique. And so far, it's working well. We've been testing it on Ingenuity, and then today it worked well. So we're going to proceed in that direction. In terms of the duration, yes, we have a 30-day experiment window, and so we have about 2 weeks left. And we believe we'll be able to squeeze the next 4 flights that we have planned. This increasingly bolder flights, we want to go hundreds of meters out towards the end. We do want to push it, and I believe we have enough time.
Like I said, man, Mimi's into it. It's freaking awesome.
In the next 2 weeks left. So again, thank you to
Discovery,
Ken
go and
Farley,
throttle up.
the Perseverance rover team. We will be done in our month, and the rover needs to go on for his primary mission. That's is very important. So that's the plan.
Okay, great. Yes, we have a month of Ingenuity.
Cool.
And still some time left. All right. Our next call comes from Steve Gorman of Reuters. Go ahead.
Hi, hope you can hear me. Thanks very much. I just wanted to know, I'm not sure who to direct this question to exactly, but are there practical implications of the success of Ingenuity, not only for expanded, enhanced Mars exploration, but for similar modes of aerial exploration on other worlds, such as Venus or Titan?
Bob Bellroom, our chief engineer. Bob, do you want to take that?
Yes. The general technique of aerial flight is applicable to places like Titan and Venus. The specific vehicle, I think, will be quite different. Titan's a much easier place to fly, easier even than Earth in some regards. And Venus, has, depending on where you want to fly, has certain temperature issues. So the specific designs and will be quite different. But yes, this does open up that doorway. And I think the bigger lesson here, I think, is also how do we operate these vehicles? How do we test these vehicles? So there is that kind of knowledge that we have learned from this process of flying Ingenuity that will definitely transfer over and be useful for the folks who will be considering missions to those places.
Congratulations.
Okay, all right. Thanks, Steve. Next up, we have Mike Wall of Space.com.
Thank you all for doing this. Just a quick question for probably Justin. Could you just kind of talk a little bit about how difficult it was to get those shots? It seems like everything is perfectly centered and everything worked extremely well. And I know you guys practiced the way.
You really lucked out, guys.
And a quick second one. Do you guys plan to actually try to capture audio on the next flight? Whenever it happens?
Another good question.
Thank you.
It's not crane clicking.
That's
Shut
a good
up.
Question. I can tell you from firsthand experience that was harder than it looks. In fact, I think I speak for our entire imaging team that we're kind of relieved that we caught it in flight. We had practiced this 3-4 times before, and this was the first time that we were able to nail it. I think it's an interesting problem. You have 2 different spacecraft with 2 different time. They both have this roughly the same time, but they operate differently. And so characterizing how the heli operates when we tell it to go compared to how the rover does its thing is actually tricky. And I mentioned before, we had to do this with the Sojourner rover too. 2 different robots with their own system. We had to do the same thing here. And
it's not crane clicking.
We kept trying and over. And
you guys don't know me. You don't know what I'm doing. I could be shooting a message to somebody. I could be typing.
And so we ended up doing a mixture of both. And the fact that it worked out so well is just amazing.
Then what is it? Maybe I'm just tapping the keys.
To be able to show these videos today.
It's not crane clicking.
That's the long answer. But it was tricky. I'll just say that. And like I said, we're all breathing a sigh of relief. The second question was, what was the second
I don't need to
question?
take this.
What's that? Oh, the microphone, yes. We do have a microphone, and there is a plan to record the sound. We didn't want to put that into the first observation or the first try because it was complicated enough just trying to get the video to work. And so we're going to be putting that in an upcoming plan. I'm not sure if it'll be the second flight, but it's certainly one of our later flights. We have two microphones. We have the EDL cam microphone and then the super cam microphone. And I can tell you the microphone owners are very eager to try. And so we're waiting in the wings to get them to get a chance to record it.
And that goes along the lines of, starting out conservative and getting bolder. And one concern we have is if we turn on the microphone, just in case there's a chance of, EMI interference between the microphone and the helicopter flight. So we really want our a few birds in our hands, and then we'll play with the microphone at that point.
Okay, great. Okay, next caller is Paul Brinkman of UPI.
Hi, yes, thanks for taking my question. Mimi, I guess I would like to know, you kind of hinted at this several times. Do you actually want to or expect to see Ingenuity crash at some point because you've pushed it to its limits? Is that kind of like the ultimate test to see how far it can go, or what do you ultimately think its fate will be? I've heard some people just in idle conversation wondering if it could tag along with Perseverance to stay in communication range. So what will its ultimate fate be?
Well, my current view, I believe, we're together on the team. We do want to push it to the limit. And ultimately, Thomas, Mike, just getting your permission. Really, because by going faster, further, our models are checking out at this time. They look good. They matched, our models match what we saw in our test chamber. The flight today perfectly matched, what we were predicting. And so, but we want to push. We want to push against the wind. We want to push against the speed. And ultimately, we expect the helicopter will meet its limit. But that information is extremely important. This is a pathfinder. This is about, finding, is there any unknown unknowns that we can't model? And we really want to know what the limits are. So we will be pushing the limit very deliberately.
I think it's also important, and I think I just want to tell you this plan was put together by Mimi and her team, and I just want to tell you it's also important and totally supportive of that plan to actually deal with this like a tech demo. We really want to be sure that when everything is said and done, we know the full scope of what's possible with that type of flying machine. And so for us, that's really critical. And for me, kind of really putting kind of a scope, a constraint around it, like the month of Ingenuity is very much in the spirit of a tech demo. That's exactly what you would want to do, right? Kind of to make sure that in fact we're putting the pedal down and are going for it. And I just applaud the entire team and of course, the entire Perseverance team to basically who are part of this experiment. So I just can't wait to see what the next flights are like, Mimi, and as we go forward, how this story will go on.
All right. Well, in the spirit of sort of casting ahead, I'm going to take a social media question, and I think this one's for Bob. Space Tourism on Instagram asks, do you think you will be able to scale up the concept and fly heavy payloads, and by when?
Yeah, so the fundamental, dynamics of these vehicles does scale up to fairly reasonable sizes. So we are thinking of things in the 25 to 30 kilogram class, which is, about the 50 pounds type of class of vehicles. And those vehicles would carry maybe about 4 kilograms of science of that order, about 10 pounds of science instruments. And so early design work on that has started in terms of conceptual designs and to see what would it take to deploy these and operate them. And so that would be, I think, a good sweet spot for the next generation design. Anything much larger, the packaging of the blades and things becomes quite awkward, so may not be quite feasible in the near term. But definitely something in the 50-pound class compared to a little 4-pound Ingenuity is definitely something that's very feasible and is actually like some early progress has been made in that direction.
Great. Thank you, Bob. Another social media question this time for Mimi. Pete on Twitter asks, What has been the most challenging part about this process? What is the most interesting thing y'all have learned from this flight?
Most challenging, well, I think Bob can answer it. First was meeting that 4-pound, that 1.8 kilogram limit. Theoretically, it was proven, it is possible to lift, build a helicopter. We knew early on from analysis. The real question is 1.8 kilogram. And Bob, as the chief engineer, managed those 1,800 grams. And I once saw him arguing with Eric Archer, who, again, we have lost, sadly. Bob, do you remember? Was it over 2 grams or 3 grams? Eric wanted this telecom hardware that was 2 more grams or 3 more grams, and Bob just wouldn't give up. So anyway, it made a huge impression. So the biggest challenge was the mass to start with.
Okay, yes, sounds like every gram counts. Okay. All right, we're going to go back to the media lines, and next up is Amina Khan of the LA Times.
Hi, can you hear me?
Yes.
Hi, thanks so much for taking my question. I have a couple. We've touched upon this a little bit already in some of the questions.
Discovery,
Just
go at throttle up.
In your wildest imaginations, we talk about Sojourner being the trailblazer for all these other rovers, and all of the ones that followed have been so sophisticated. What is the most powerful and sophisticated type of flying planetary explorer you think we might have in the next year, in the coming years and decades, and what kinds of worlds might they explore? Could you sort of wax imaginative and think about what the potential really is here in some specific but imagined ways? I'm not going to hold you to it. I won't come back in 10 years and say, hey, where's my flying rotorcraft on Neptune or whatever? But I'd just like to see. So where do you think this could go?
Thomas, you want to take this one?
So the first application of flying vehicles, of course, is track and fly at Titan, in which we have a very different vehicle. And Bob already mentioned it's kind of in many ways simpler because of the stronger atmosphere at Titan than the Earth even. I want to just point out one point I'm sure everybody is thinking about already, but knowing how to fly a vehicle like that may actually have applications on Earth too. I mean, it's that planet up there. At these very high altitudes, there's interesting science that I'm sure our Earth science friends are thinking about also now, and whether they're here at JPL and elsewhere. I do believe that the primary application beyond that is really going to be at Mars. And frankly, what is in my mind, right, when I look at this, is the that much of the science, when there's a lot of papers written about, from the reconnaissance orbiter, Mars Reconnaissance Orbiter, is about areas where we cannot bring a rover there. Like, crater walls are really exciting with perhaps, some people say, water seeping out there or some kind of watery mix. Like, is that really the case? Well, to actually figure that out, frankly, you want to probably fly there. The final point I'm going to make is, right after the technology demonstration, it's usually a pretty bad place to figure out how big the boxes in which the solutions live. And I was not there, of course, at Sojourner. But, we are here from 97. We're here, and we have Perseverance rover, and is basically enabling sample return. And for me, did in fact the Sojourner people think about a sample return of one of the core applications of this kind of mobility? Perhaps they did, but the point is, that is where we're investing major effort and, dollars, attention. And frankly, without mobility, I do not know how we could do this. And it's an absolutely critical science application. So the most important thing to learn about these things, it's very hard to predict the future.
All right. Justin also wanted to add something.
Yeah, I just wanted to say, 24 years from now, it'll be 2045, if I did my math right. We've been up since 2 in the morning. So I think that the people to answer that question are maybe people watching this press conference right now. The kids in school, the kids studying, working hard, learning about science and technology. I think the answer to that question is up to you. So those of you that are getting inspired by this, go into fields of science and technology and decide for yourself what does the future look like. I think that's what the group here did, and we just try to be an example to those watching to give you that opportunity to answer that question.
Thank you. And just a clarification on Ingenuity and testing it to the limits. Are we looking to fly it as far as possible or as hard as possible, if that makes sense?
It is a question that I don't think we're fully decided on yet, where exactly we want to push it. As I mentioned before, you can talk about flying higher, you can fly farther, you can fly faster. Those are three particular areas where we'll be looking to in terms of possibly stretching the capabilities, assuming that things go well over the next 3 flights. That's where we'll be looking, but exactly how we prioritize between those different things, I think is still a discussion that we need to have as a team.
Thanks so much.
Great. Thank you, Hovard. I think the gist was that it's hard to look into the future, but thank you for the glimpses into the future. Our next caller is Eric Mack of CNET.
Yeah, hi, thank you for taking my call. This is looking a little bit far down the road, but I know that NASA has an entire technology transfer office and often likes to spin off its technology. So I wonder if there's been any discussion within the agency of possible applications for this technology here on Earth.
Thomas?
So I did not check with the technology transfer office, of which we're really proud. There's a number of technologies that were transferred in many different applications. In fact, I met one of my friends told me that he started a whole business based on one of these technologies. I just only learned about this recently. I would not be surprised if a company somewhere basically says, this is amazing technology, I want to learn about it, or whether or not the work is in this particular, in the research arena, like where we're working, or in other arenas that one could imagine, right? I mean, like so much of this is in the area of dreams, right? I've been thinking, I can't get out of my mind the amazing movie footage this would be if we saw somebody going up Mount Everest and seeing a kind of a drone on the outside actually covering that from there. I mean, nobody has ever seen this, how would that look? I'm not aware of any negotiations right now, but I'm sure if there's interest, the team is ready to support it.
Thank you.
Great. Okay, next caller is Stephen Clark of Spaceflight Now. Go ahead.
Thank you, and congratulations to everyone. Stephen Clark, Spaceflight Now. A couple of questions. One for Hovard. Do you happen to know the velocity, vertical velocity at takeoff and touchdown of the helicopter? And also, maybe Mimi Yang can refresh my memory on the flight plan details for flights 2 and 3, since you have those, I think, already planned out. And just refresh my memory on the altitude and distance planned on those. Thanks.
So I think the question was about the philosophy for takeoff and landing for Ingenuity. And so to take the takeoff first, the way that we take off is we boost off the ground with the fixed, what we call collective setting, that basically provides a thrust that's well above what the aircraft needs to hover. So it sort of boosts off the ground with limited control in that very initial, split second. And then once it separates from the ground, against just a few centimeters of altitude, then we take full control of the vehicle and guide it up to the altitude that it's going. And that is because we don't want to be fighting against the ground with the legs on the ground. We don't want to be fighting with it by applying full control at that point. We want to separate cleanly, get out of ground effect, and then continue controlling. On landing, our philosophy here is to basically fly towards the ground at a constant speed. In fact, Ingenuity is commanded to fly through the ground and then just stop doing that when it detects that it's not able to do it anymore, because that means it's met the ground. So it uses the onboard inertial measurement units in order to detect that it stopped making progress downwards, and then it instantly lowers the collective to stop producing thrust and settles on the ground.
And then on the flights 2 and 3. The second flight is to take off like today, except higher to 3 meters height instead to 5 meters height instead of the 3 meters height that we went up to. So we'll go up to 5 meters height and then fly laterally for about 2 meters, come back the 2 meters and land from where the exact spot that the vehicle took off on. And then following that, flight 3 would be again to go up to 5 meters and then fly laterally 50 meters out and then come back 50 meters and come back. Any other description you want to add to those flights, Howard?
Yeah, no, that about captures it. So it's sort of taking things stepwise. Again, the next flight we will be testing higher altitude, so that will be one aspect of it, and then the ability to track to different waypoints that aren't co-located like we have here. And then for that third flight, we would be translating further, and at that point also faster. Normally 2 meters per second is the forward velocity that we'll be using for that third flight.
Okay, thank you. We're going to go to another media question from Joey Roulette of The Verge.
Hey, thank you for taking my question. This one's for Thomas, and it kind of echoes some of the other questions already asked, but from a broader perspective, how much more confidence does this flight give you for sending more helicopters to Mars or other planets? And for Mimi or Havard, what exactly does pushing Ingenuity to its limits mean?
That was already asked.
How high, I guess, could it go based on the data that you guys are seeing now?
That was also
and
already
is there anything
asked.
that you guys are seeing in this data that kind of tells you what those limits might be? Thanks.
Hey, Joey, really appreciate the question. Look, I mean, I think of exploration, there's a box somewhere in my mind in which kind of all the things we know how to do are in that box. And kind of every mission that we're flying is a combination of the things we've already proven.
And you can't look in the box.
Since this morning, there's an entirely new tool in that box. And it should be combined with the other things that are there. And I'm very confident that great ideas will emerge with that technology proven here for new missions. I would be very disappointed in the science community and the technology community if they didn't come up with something utterly amazing because of the new dimension that was added by this technology to explore. So for me, I'm confident we'll see a lot of this as we go forward. What it is exactly, I can't tell you today.
Yeah, so again, in terms of how far we challenge it and what direction is still a little bit of a discussion, but what I can say a little bit about is, what are the things that we are challenging, if we go, say, faster with the helicopter. One of the things is airspeed. The aircraft is, tested up to a certain airspeed. And so by going faster, we would be challenging those limits, and that challenges the aircraft in terms of its stability margin, its ability to handle those larger airspeeds. Another aspect that we're challenging in that regard is the navigation system, because as I mentioned before, we navigate by taking images of the ground below. And as we're traveling faster over the ground, those images, the features in those images disappear from view faster. And so that's another limiting factor, if you will, that we're pushing up against as we start to go faster with the helicopter. In terms of altitude, a main limiting factor there is our altimeter, which is actually a laser rangefinder that measures the distance to the ground. And so we're limited by how high we can fly before that stops working properly. And so nominally there, we're looking at probably somewhere, at 10 meters or a little bit more, but not much more than that before we would start to run into limits with the laser rangefinder.
Well, to put a number on the distance of it, I'd love to push it to 600, 700 meters. So just putting it on the record. Okay. So anyway, this is the further team discussion we're going to have.
I'm being more cautious here, but I'll take that discussion.
600 meters.
Okay. All right. Thanks for that. Next caller is Guy Norris of Aviation Week.
What's up, Guy?
Yes, thanks for taking my call, and congratulations on an amazing achievement. Obviously, you are at the beginning of the first ever extraterrestrial flight test program, I guess. And one of the things I was wondering about, just to go back a little bit to what Mimi was saying, was the lessons learned. You know, how quickly you'll be able to draw on these lessons learned for the following flight test program. For the following flight test. Specifically, the RPM, the liftoff RPM, and the descent rate that you saw on this first flight. Will you be able to basically work on analyzing whether those were within predictions, as you said? And the last part is just, could you say what these vertical velocities were on liftoff and touchdown?
Yeah, so we will be getting, so the data that we've seen so far is actually fairly limited. We will be getting, in the next few days, we'll be getting a lot more data down from the helicopter, and that'll tell us a lot about how it performed. So in relation to the RPM, for example, the RPM is set based on what we expected the density to be at the time of flight, in order to put us in a particular operating regime. And so what we will see when we get data down is we'll see what did the helicopter have to do in terms of the controls operating at that RPM. Were we operating at the set point that we thought we would be, or were we off from that? And that'll tell us, among other things, you know, something, it'll at least tell us to what extent was the RPM appropriate for the density that we were at. So that's one example of that. We'll also get a lot of metrics that will help us analyze the navigation system and see how well did it do at tracking features on the ground during flight. And then I didn't actually hear the last question that was asked, if you could repeat that.
It was really just in terms of the velocity, really, of but as you said, I think you're still going through the data. I just wondered if the touchdown did seem rather sporty in terms of the descent rate, but I presume that, as you mentioned, is part of the philosophy of how you approach that landing sequence.
Yes, it is. It definitely is. So we descend at 1 meter per second, and as you know, in terms of sportiness, you can see we don't slow down when we start to near the ground, and there are multiple reasons for that. One of them is we just don't want to hang out too long in ground effect. Another reason is we are assuming that we could be obscured by dust when we're operating close to the ground. Now, as you can see from the images, we don't see much indication of that, but that's been our long-standing assumption, and for that reason we don't use the camera or the laser rangefinder when we're near the ground. We're just operating based on what's called inertial measurements, and those tend to drift very quickly. So we want to get, when we're in that mode, we need to get down to the ground quickly. So that's another reason to just aim for the ground at a relatively high velocity and not try to slow down too much in the process. And the third reason is because we're sensing that we're meeting the ground, we want to do that confidently. If we just barely touch it, it's hard to detect that that's what you did. And so we touch down confidently. We can very easily detect that we did so, and then we can stop flying.
Okay, all right. We're going to take a social media question here. This is for Mimi. Donnie on YouTube asks, what advice would you give for girls and young ladies in school around the world who are interested in pursuing a career in space-related technology?
My advice, if you're attracted to it, go for it. Don't let anybody talk you out of it, including yourself. So I like to say, find an intersection of what you like to do, what you're good at, and the cause that you want to, make and improve on. Find that intersection of those three. When you find it, like it sounds like you are attracted to STEM, go for it. And it takes tons of hard work, but it won't feel like hard work because you're going to enjoy it so much. Your passion's going to come out of it, and you will be able to make whatever you want to make happen. So yes, my biggest advice, don't let yourself talk you out of it, and definitely don't let other people talk you out of it.
Thank you, Mimi. Okay, we're back to the media lines. Rick Lovett of Cosmos Magazine. Go ahead.
Yes, thank you very much. My question has already been answered.
Okay, all right. Then we will take the next media caller, Leo Enright of Irish Television.
Leo!
Thanks very much, Jairi, and congratulations to everybody. I have a semantic question for Bob Balaram. Some people may not realize that we journalists are people who look over our shoulders and check what we write. In Europe and Asia, we call these people sub-editors. And my sub-editors want to know, why do I keep calling this a helicopter, and why do I not call it a drone? Can you help me answer that? And Jairi, if I could ask a second question.
Because it's got a swash plate.
To Justin Mackey, to know, where is Perseverance going to be during this extended flight test program? Is it going to stay in place, or will it move around between
I am
flights?
a swash plate, yes. It's because it's got a swash plate.
So purely as a terminology, whether you call it a rotorcraft or a helicopter or a drone, you could use those interchangeably. I think one of the connotations of drone here is that it's has a little bit of an off-the-shelf. You go buy it at your favorite store, and you can fly it out of the box.
My favorite store
is quite different. It had to be designed from the ground up for a very alien, very harsh environment. We don't have drones that survive minus 130 degrees Fahrenheit at night.
Heli rotor drone.
We don't have drones that fly in 1% of the atmosphere of Earth. So if you're careful about using the word drone, and you remember that this is a very, very, very special drone, you could say drone. But just want to make sure that people don't lose track of the fact that it's a very special aircraft that's quite unique. But if you want to call it a drone, helicopter, rotorcraft, depending upon your community and your audience, feel free.
Okay, and then Justin, you want to?
Yes, so the rover is actually going to stay at its current location during the next few test flights. This location was actually, there was a fair amount of discussion about where to park for the duration of the month of Ingenuity, and the science team spent time debating that and picked this location. There are a lot of interesting nearby rocks that the team has actually been, over the weekend, doing a lot of interesting discussion about trying to understand where the local geology, and they're keeping very busy actually. I will also mention too that this is giving the team a chance to just look at all the data. We've been using Mastcam-Z and the SuperCam RMI remote microscopic imager to take really detailed pictures of the delta remnants. And there's been a lot of discussion about which way should we head into the delta. Should we go one way or the other way? And so this is giving the team a chance to get caught up on all of that too. So we're going to be parked right where we are. We like this location, and I don't know if any of us mentioned, the heli is about 70 meters away from where we are right now, 69 to 70 meters. So we like that vantage point. As you can see, we get a good view of the heli, so we're happy with the current location.
Okay, we're going to take another media question. This one is Rose Ann Aragon from KPRC TV.
Thank you so much for taking my question, and congratulations. This is sort of whoever would like to answer this. I understand that you have done hundreds of simulations of this. I'm interested to know, is there something that you have learned that's significant that was not in line with what you had predicted with the simulations, other than the dust and the cameras, of course?
It looks like, like it did in simulation. It's, again, we're going to get more data, and so we're going to mine through that, and we're going to learn things from that, and there may be things there that are unexpected. But just looking at what we've seen so far,
are they data mining Ingenuity?
It certainly, flies very much like what we predicted in our simulations, which is really great. And as far as the dust, yes. Our fears about having obscurations from dust near the ground do not seem to be borne out. We always knew that there was uncertainty with that, and we always took a cautious approach to it in terms of how we designed it. And I'm happy that we did. But it doesn't seem like the worst concerns in that area came true.
And just to add to that, this morning, Jaco Karras, who was looking at the telemetry from the motor and the servo controls, he said telemetry just looks exactly like what we see in the chamber. So anyway, it is looking really good, and but we'll be scouring through the data. This is what Tech Demo is about. So we will be looking at the high definition, high rate data over the next few days.
Justin, do you want to add something?
I'll just add, from the imaging point of view, we've learned a lot from this first flight. It's very hard, as you might imagine, it's very hard to simulate a helicopter at 70 meters, full speed, spin, to get the timing. And so we're going to take what we learned from our imaging today, and we're going to work to improve the additional flight imaging attempts. So stay tuned, and we're hoping to have even better video to show.
Great, okay.
Thank you so much. And
go ahead.
With the full scope of understanding the vehicle itself, where will this helicopter be the most productive and that would bring the most information on Mars?
Go and see the sky crane. Please say see the sky crane. Please, I want to see the sky crane.
There are many areas on Mars that, frankly, we would like to have more information about. And that information is not accessible in any fashion by rover. And so for me, if I was to make a prediction, and again, Yogi Berra said it's hard to make predictions, especially about the future, and that also applies here. But
dude,
if I was to make a prediction,
Yogi Berra reference?
The first type
what
of
a legend!
Are in one or another location like this, especially crater walls or specific craters where we just can't get in. And we would like to see what's there and how the walls are composed. But
yeah, maybe.
somebody else may have a different idea here on the panel, or I'm sure in the science community with 10 scientists will have 20 ideas.
Okay, thank you. All right, we're going to take another social media question. Maybe Mimi can start with this, but it probably applies to everyone, especially the people on our video conference.
Sob's not Yogi Bear.
Stephanie Lee on Twitter says, how is the Mars helicopter team going to celebrate this amazing accomplishment?
Well, okay, I'll answer. First of all, this is the first day in our 6-7 years of effort that we feel licensed to celebrate just the way we are. Hovarth's one of them. Josh Ravitch, another one. Teddy Xenatos is another one. There are a few who have never let me celebrate fully that have always said, not yet, not yet. And so we've had a long journey. We came from a little prototype to a risk reduction vehicle to engineering development model to Ingenuity, and then how to get onto the rover, getting launched, and then surviving the launch and surviving the drop, and and here we are. Every step has been huge, and we have never allowed ourselves to celebrate fully. So yes, we will be celebrating 100% fully. We're authorized for the first time. But I'm sorry to disappoint you. We don't know what our party plan is. At least a WebEx happy hour. Now, Bob, do you want to chime in? Bob is usually, can you tell? He's our chief engineer and innovators. He always thinks out of the box. I don't know, Bob. What should we say?
Oh, I don't know, Mimi. I think we could look to you for leadership even here.
Then we're in trouble.
That was a boss answer.
That's a good question.
Well, I know we're under COVID conditions, but hopefully you could see everybody smiling under their masks. All right, we're going to go back to the media lines. We have Kin Song Lee from Hong Kong Cable News. Go ahead.
Hi, thank you. I'd like to ask, what's the meaning of this flight for the aerodynamic studies? And I hope you could explain a bit more on whether we could fly other kinds of aircraft on other planets. Thank you.
Hovarth?
Yeah, so it's very significant in terms of validating, the aerodynamic modeling that we've done in this project. So, I say, it looks like what we've simulated. And that's great because it validates, the work that we've done. It means, we got it right. And that is a huge thing in this case. And we'll of course learn more as we get additional data and do additional flights for that. And as far as doing flights elsewhere, I think maybe Thomas could comment on that.
So I think there are a number of flights we would like to do on Mars, right? And we need to figure out what the right places are to go. and the right applications for that. And my hope is that science communities around the world are starting to focus on this. Going to Titan is something we're already working on right now with a vehicle called Dragonfly that is under development. And even though that's a very different atmosphere aerodynamically, a lot of the lessons learned here is how to test these vehicles and how to get them ready and actually put them in place. I think a lot of these lessons learned here are actually utterly applicable. There's other bodies, of course, in the solar system with atmospheres, and I would not be surprised if great ideas can come about to go to these as well. But those are the two obvious places to think about right now.
Okay. All right. We have another caller on the media lines, Ken Kramer of Space Up Close. Go ahead.
Thank you very much, and congratulations to the whole team. I have a question. For the fifth flight, if you get that far, is there any possibility that you might fly the helicopter towards the path that you're going to drive the rover and then drive past? If you do that, would you then drive up to the helicopter and take some pictures of it and inspect it and see what it looks like? And for Thomas, do you have any room on the 2026 lander for a helicopter? Thanks.
Well, for the fifth flight, after as much as I can push Hobart to go as far as possible, I care about going really far and really fast. That number, which I'm really hoping is 600 meters kind of distance, and as fast as we can go is what we care about. I have to say I did share with Ken Farley and Mars 2020. We don't care which direction. We really want to push the helicopter flight in the distance. So I would like to turn the question over to Ken Farley and Mars 2020 folks, if there is a preferred direction. So that is a conversation to come. So from our perspective, we want to push the distance and the speed. So stay tuned.
So you asked me, hey, Ken, you asked me about 26, or the Mars sample return campaign. I just want to tell you, the Mars sample return campaign, the most important thing we need to do is keep it streamlined as possible. There's a lot of things we could be adding to this, and science instruments, this and other things, and frankly, the campaign that we have in front of us is very much focused on exactly one key objective, and that is to bring the samples back to Earth. And everything that we're doing is supporting that objective. So technology demonstrations, are a really critical part. I think Mike Watkins said it well at the beginning. We want to see wherever we can do it. I just want to also mention that for many missions, focus is a very critical part as well. And so often, what we need to do as explorers is have two opposing thoughts in our minds at the same time. So that's what's going to happen here also.
Okay. All right. So thank you. We're going to take another media question. Manuel Mazzanti from Debate.
Hello, everybody. Congratulations. NASA, JPL, the entire team, even the guys remotely. This is an historic day. Mimi, your enthusiasm is contagious, definitely. A question for you, or maybe for Howard. The 96-degree rotation of the helicopter was done to see how the helicopter responds to certain commands, or was it done to point the camera towards the rover? And I wonder if we are going to be able to see the rover from the Ingenuity perspective.
So we wanted to make a turn because it goes a little bit further than just a straight up and down flight. And the particular turn that we did there, the 96-degree turn clockwise, did put the camera, the return to Earth camera, pointed towards the rover. We did not take a picture with that camera during this flight, but it does set us up for potentially doing that for the next flight. As far as whether we will see the rover or not, it depends a little bit on exactly the state that the helicopter is in when the picture is snapped, because the camera is angled downwards at an angle where it doesn't see all the way to the horizon in level flight. And so you have to get a little bit lucky to catch the rover in that image. So we don't have any guarantees that we will actually have that.
Thank you.
Justin?
I'll just add one thing to that, because people do ask that question about imaging the rover with the camera. The original intent or plan was to have the camera rotated in portrait mode, so that the long end of the field of view would look up just above the horizon, and we would take the picture of the rover. But late during development, and Bob can even talk about it a little more, there was an issue with the configuration, and it had to be changed and mounted in landscape mode. So that's the story of why it is tricky to get that picture of the rover itself.
Okay, great. Thank you. And thanks to everyone for all of their questions. If you're a member of the media and you still have more questions, you can contact JPL's Digital News and Media Office. We will help you get interviews or everything you need. And if you're on social media, we'll continue to answer questions with the hashtag Mars Helicopter online. So thank you, everyone, for this. And for more on Ingenuity, you can visit go.nasa.gov/Ingenuity. We'll put the latest updates there. And if you want to learn more about the Perseverance rover, visit mars.nasa.gov/Perseverance. There's a link in there to the raw images. And so if you too want to drink from the fire hose, we have a place for you to go. All right, and if you're on social media, you can join our conversation at NASA JPL. Again, you can use the hashtag Mars Helicopter. Thank you for watching, and go Ingenuity.
Just remember, guys, they did helicopter on Mars. Oh, wait. One more thing. One more thing, Jackie. That's so freaking cool. Dude. Oh my goodness. That's so legit, man. The rover did film that, yep. Is that something else? So they're gonna hop it again, and again, and again, and then probably break it. That was the whole flight, Evil Rays. It was slowed, it was shorter a little bit. So the thing took off, hovered for 10 seconds, turned 96 degrees, hovered for 20 seconds, and then landed. So it's 30 seconds total of flight. Pretty cool. Is it a helicopter or a drone? I would call that a helicopter. I would call it a helicopter. The reason why I call it a helicopter is because it has a swash plate, okay? Swash plates indicate variable pitch on blades. Drones, from what I understand, do not have that. Drones use a fixed blade, so the blade doesn't move, okay? And then they use a bunch of blades to be able to move around. I would call Ingenuity a helicopter because its contra-rotating blades have variable pitch. So that means it has a collective and a cyclic, which, that's a helicopter. Do you think man-Mars helicopters are feasible? You'd need big blades, dude. Who cares? We're flying on another planet. Call it magic for all I care. We're flying on Mars. Sure. They did helicopter on Mars, guys. They did helicopter on Mars. Okay. And I wasn't crane clicking in KSP for what it's worth. Alright? I was getting stuff in place. Getting my shuttles back. Okay? I love the press. Just on a side note, half the press questions, it's like, okay, we did a test flight for a helicopter. What was the first time you flew a helicopter on Mars? Well, we just did a test flight. Oh, great. When's the second helicopter going to Mars? You can ignore me, you crane clicker. I'm not a crane clicker. Not yet, at least. How come we don't see the dust kick up? Is it because of the temp of the atmosphere? There's wind, Faust, but it's not, it's not going to be like here. It's not, the thing is, there's just not that much air to move. 1% of Earth's atmosphere. So we're at like maybe a quarter of a pound per square inch, which is just like, what would that be in kPa? Like 0.1 kilopascals or something. There's no air to affect the dust. There is dust on Mars. It's just, I mean, I'm not sure even the cameras could pick that up unless we had something in like 4K or something. It's 800 pascals. Yeah, that's nothing. That's nothing. You can't breathe in that. You can't breathe in that at all. Do you think any press people truly realize how hard it was for that flight? Some of them maybe. Yeah. Bill Harwood, I think Bill knows. I think Bill understands what's going on. Ken Kremer definitely understands what's going on. How many atmospheres is that? Okay, Kelly, Earth, the air you're breathing right now, that's 101 kilopascals. So that's 100,000 pascals. It's 800 pascals, not 800 kPa. 800 kPa, you die. I mean, to be fair, 800 pascals, you die as well. Kelly, we're talking like maybe a quarter of a pound per square inch at best. It's nothing. Who is Pascal? Oh, we're talking about Pascal Wehrlein, the famous race car driver. Yep. Yes. I want to see the sky crane, Zonku. I think it would be cool. .8%. So yeah, 800 pascals. That's ridiculous. 0.1. So 16th of an inch. 16th of a pound per square inch. Jeez. What was Pascal's famous quote? I put pressure on my opponents.
Discovery, go at throttle up.
Robbie, 6-month resub. Ciao, come stai, mi amico? Pythos, I am in disgust. I am disgusted. 1/6 of a PSI. Bene, ciao. Right on, man. Hey, Ferrari, dude. Ferrari coming up strong in the Formula 1 race. Too bad that red flag made Charles lose the podium, but hey, whatever. I'll take 4-5. That's fine with me. Better than last year. Much better than last year. All right. I just got an email confirming you got a job. Hey, all right. Hell yeah. KSP or early space news? Well, guys, we got to put this Freedom 10 to the test here. But it's 3:30 now. Yeah. Oh, okay, Brian. Well, Twitch streamer did really good. Lando did really good. He is streamer now. You know what's funny? Brimo watches Formula 1 with me just because Brimo likes Twitch. Hi, Brimo. And she knows that Lando streams on Twitch. And she doesn't call him Lando. She just calls streamer. Full-time streamer. F1's just a hobby. That's right. Is that the Russian racer? Yeah, yeah. Yeah. I miss him and Carlos. Your aunt cut your hair today. You now have a mullet. Yes. Yes. Yes, look at it. Oh, yes. It's coming back, dude. Mazza spin. He didn't go out in Tosa like I said he would. How many times he's gonna crash the freaking car? I don't know. Yeah, it doesn't take pressure at all. It's like a habit to me, so I quit when I don't like it. I mean, I watched because of the drama in Drive to Survive. Oh my god. Any news on when SN15 will launch? Wednesday, I think. Alright, guys. I'm going to take a break, I guess. Yeah, well, I'll take a break now. We'll do space news, and then we gotta jump in. So it's better to get on this a little bit earlier. Alright, so let's start the space and rocket review. Space and rocket review. I'll switch this over there, and EJ, did you know they did helicopter on Mars, dude? Like, I'm not trying to undermine it. It's just amazing. Like, that's amazing. On the server, where's the road going after it narrows? Power. Let's see. I'm thinking about how I should expand the Navy pier, but all the directions I look, it would block other ships' paths and get close to the oil rig and the Guardians. I'm stumped. I'm also thinking about building a bridge to a different island that you are not using and turning that into a second pier. The road that narrows, Pi, I wanted to do this. Do a little left and then right. And then that road will turn with the main road and connect in right here. So go up here like this. And I need to make room so Thomas builds the boathouse right here for all the tugboats. So make it go out here like this and then turn and connect in right there. That's what I need. Drool, in terms of expanding the pier, yeah, we have an oil rig, Sevi, of course. See? Yeah, there's more pier out here, and then we got to make the bridge. We got to make the... where's the two closest spots? The closest spot is right there. So the highway might need to go this way. And then go like that. Where's the resupply boats for the anchor handling tugs? Right there. Pilot boats and tugs. Hey, Jackery. I'm doing all right. I have the ULA news. Let me look. We could, okay. I'd say finish these piers up over here, Drool. Get with World Killer. Work on this stuff over here, and we can expand it. But remember, guys, I want a bridge We want a high bridge, like a big suspension bridge that goes right here. Or somehow, maybe the bridge can go that way. And we could fill in some land here. But yeah, we gotta figure that one out. Anyway, fellas, I am going to take 30. Well, 20. I gotta cook some food. I'll be back at the top of the hour. And we will, we gotta do a little bit of space news. There's a couple of things here and there to talk about, and then we really gotta test this new crane out. I gotta get that tanker up into space today, and we really gotta evaluate its performance. That has to get done today. Got the NASA space flight vid. Got it. All right. So, I'll be back in a second, and we will get going. I'm just kidding. I'm just kidding. Back to chirp.
Discovery, go at throttle up.
Hello? Hello? Cello? Cellos? Who's playing the cello? I don't have a cello. I have this. Well, okay, I do. I have this 6-string cello right here. Why is your door open? My door's open? Why? Well, shut it. Shut it then. No, you're closer. No, you're closer. No, you're closer to the outside of the door than I am, okay? The camera's not on. You have time to go beat me up. No, I'm documenting everything on video evidence to make sure that I don't get abused. Document. Brimo, come. Brimo, you gotta shut the door. This is important. I have to stream. Oop. Oh, fine, 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 mine, 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 mine. Why don't you shut the door? You're sleeping on the couch tonight. You're sleeping on the couch. I banished you to Couchland. It's my bed. Yeah. Yeah. Yeah, you're sleeping on the couch tonight. That's how this works. I write the book, okay? You came in and you're fired. You're fired. Hey guys, did you know that they did a helicopter on Mars? Here, check it out. Sneaky! Sneaky, they did helicopter on Mars. They also did surgery on a grape. Wait. They didn't get sound this time around. They didn't want to test it, so here. Here, let me just make sure I got the right thing. All right, here. Yep. All right. I got the right.
Discovery,
Here
go
you
at throttle up.
I got the sound for you. All right. We will dare to do mighty things here, okay?
My rafflecopter goes swa 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 swa
They recorded it. I swear. Why would you do this? Why would you do any of this? Because they did helicopter on Mars, man. It sped up right when it took off, too. I don't know, man. I don't know. I don't know. Can I just one more time, please? Oh my God.
My rafflecopter goes swa 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 swa.
Oh my God. One more link. Okay, I got it. Oh boy. So, all right. Why is this funny? you need help, but my raffle.
My rafflecopter goes swa 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 swa.
All right, not everybody apparently got that joke. Cease! Stop this now. All right, so, okay. I have to center my chi. All right, now, so early this morning at 6:30 a.m. Eastern Time, JPL got word back from a test that was initiated 3 hours prior of the first flight of the Ingenuity helicopter. So that's what this is here. Ingenuity took off, hovered, and keep in mind this footage is a little not compressed, but it's not footage. It's just a bunch of pictures kind of stringed together. It took off, hovered for 10 seconds, proceeded to turn clockwise 96 degrees. Watch, if you see it, it turns. See that? You can see the thing turn. And then hovered for another 20 seconds and came back down. This is the first of a bunch of flight test demonstrations coming from the Ingenuity team over at JPL. They did confirm the next couple of flights, what they're going to do. The next flight is going up to 5 meters and then translating over and then going back and translating down. And then after that, they'll do a slew of tests that push the vehicle further and further and further. And they said they have a range of up to 700 meters from the Perseverance rover. Perseverance in this shot was about 70 meters away, which is, I mean, that's why the footage is not ideal, but they are still analyzing data. They're still analyzing, grabbing all the data from Ingenuity right now, including camera shots from the drone looking at the rover. That's why they turned it. They turned the rover 90 degrees counterclockwise, or turned the helicopter 90 degrees They turned the helicopter 96 degrees clockwise so they could get the camera on board Ingenuity to point at Perseverance. And Perseverance was looking at it with its mast cam, which is really cool. No, it's not 96 degrees is not entirely random, Belgian. The 96 degrees comes from just being able to turn the rover and turn the helicopter and point it right at the rover. Yeah, the rover drove away a little bit, and how that translated into turning the camera and looking at the rover translated to about 96 degrees. It's not a significant. It's not like, oh, it had to be 96 degrees. It ended up turning 96 degrees because they were trying to point the camera at the rover. That's what's going on. Does Ingenuity have a GoPro? No. Ingenuity has custom-made optics that were made at JPL. I don't know what they're based off of exactly. I think they're in-house. If I heard what I think it was Jason said. You guys got all this in the press interview, right? You guys remembered all this? I didn't write any of this down. I was playing KSP. You did hear some crane clicking, but it wasn't the crane clicking you think that. How come I can remember all this off the top of my head, but the reporters have to ask questions twice? Except for that one dude. That one dude was like, "No, my question's already asked. Good job, guys." Tessa, if I tell you to approximately be quiet, is that a nice way of saying shut the frick up? Now, imagine turning on an automaton just to play 2 notes and turning it back off. What Boris is trying to tell you is that it's time for the Russian news. That was the big news coming off the top of the news feeds here. I mean, that Ingenuity test was really good. Also, Boris, thank you very much. He says yes. All right, so let's flip over to the Russian news and see what's going on over there. So this is coming from Dmitry Olegovich. What's Dimitri saying? Science module is getting ready to go to the vacuum chamber. I know because of a previous article translated. I would guess that if they're lifting it up out of payload processing, that it's ready for the vacuum chamber. Oh man, I'm good at this. Yeah, I already knew what that said. Not the only big news today, at least a positive one. Yep. They did a helicopter on Mars, LQ2. Yep. Okay, so let's see what they got. So the science module Nauka. Nauka is just a Russian word for science, and I know I'm not saying it exactly right. It's like Nauka or something. Kim, I can't get it right. I'd have to hear somebody say it. Here, hold on. Let's see if Translate does it right.
Veda. Nauka.
Like that?
Nauka.
Huh.
У меня есть большая кошка.
Yeah. Okay. Anyway. Yep. The way you're saying it is fine. Okay, cool. Alright, so let's see what we got. So look, they have the module attached to the payload attachment fitting right here. It doesn't have any of the solar panels installed from what I can tell here, or the European robotic arm, but they're gonna vacuum test all the systems on it before they do that, before they prepare it for final checkout. But it does have the Proton launch vehicle adapter on it, which is cool. Awesome. All right, let's see what else we got. OneWeb is getting ready for their 6th launch from Vostochny, which is the eastern Russian spaceport here. Keep your eyes peeled for them to draw closer. Music is a live stream update. Right on. Cool. All right, excellent. That's targeting April 25th. I'm gonna have to sit this one out, guys. I'm gonna have to sit this one out. It's Primo's birthday weekend. That's not happening. Sorry. I'm not even gonna try. I'm sitting that one out. I got to. I'm sorry. I don't have a choice on this one. It's on. Yeah, I'm sitting that one out. We're not doing that. Did you say Primo day of birth? Yep. We'll report on Monday. Got it. Did you hear that? Wait, what? Wait, what, Lig? They did a helicopter on Mars? Or no, wheels? Wait. Lig, what did you say? You said, hey guys, did you hear that we landed a rover with wheels on Mars? Dude, I did hear that. Did you hear that they helicoptered on Mars? They did a helicopter on Mars. All right? I got the sound for it too. Very exclusive audio.
My rafflecopter goes swa 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 swa
They recorded it with the microphone. They recorded it with the microphone, guys. They had the microphone on Perseverance and they got a recording. They did that. They did surgery on a grape. No, I would say no, that's fake, but
Discovery, go at throttle up.
you know. Okay. Oh boy. David, 24-month resub. That was demonic. My rafflecopter goes. Can somebody edit that for me? All right. Anyway, back to the Russian news. Let's see what we got. Oh no. Tomorrow is, in the early morning hours of April 20th, teams will complete a final major review of the Crew 2 mission, the launch readiness review. Let's see, let's read. Russia will withdraw from the International Space Station project in 4 years. This was stated by Deputy Prime Minister Yuri Borisov on the TV1 channel. President held a meeting on the development of the space industry on April 12th. We've agreed with our ISS partners the term of operation at the station, 2024. After this period, the decision will be made based on the technical condition of the station modules, which have mostly expired their service life, as well as our plans to deploy a new generation national space station. Okay, did we just get Did Novosti just clickbait us? Did they? You guys have clickbait too, huh? Well, that blows. Novosti just clickbaited us. It's pretty lame. Okay, let's see what else we got. Russia will work on its national station. The head of the Russian Academy of Sciences, Alexander Sergeyev, at a meeting of the Presidium of the Academy, says that he expects the start of the funding for the project after 2025. Prior to that, the need to create a new station due to technical problems in the Russian segment of the ISS was announced by Flight Director Vladimir Soloviev. Cracks were found throughout which airscapes. They've been sealed, but a small leak continues. After 2025, Soloviev predicted an avalanche-like failure of its other elements. At the same time, Russia's spending on the ISS is estimated at 10 to 15 billion rubles. Did I get that right? No. Over here. I doubt they will be able to carry two stations at the same time. Wait a minute. Did I see that right? Oh, no, it is billion. It is billion. It is billion. Hold on. No, so... I'm sorry, this has no decimals, so it's hard to look at. So 15 billion rubles is 190... So it's almost $200 million. Yeah, 196 mil. Is that per year? Once we get some better footage, Zizep, up, yeah. Seems low, honestly. That's per year. Yeah, well, guys, Russia's space program is not, it's not NASA money, that's for sure. They're planning to undock the Russian segment, discard old modules, and use Nauka or the NEM or whatever the new module is called, Prichel, and one more. Well, this sucks. It's not so much efficiency, guys. The cost of living is way lower over there. Prices correlate to cost of living, guys. You got another one here. Roscosmos commented on the announcement of their withdrawal. We've agreed with our ISS partners the term of operation at the station. After this period, decision will be made based on the technical condition of the station modules, which have mostly expired their service life, as well as our plans to deploy a new national observation station this generation. We will make a decision, then we will start negotiations with our partners on the conditions and forms of interaction after 2024. Unfortunately, the petrochemical industry pays its engineers a lot better. Same could be said over here, Kamir. Make a lot of money. Heck, over here, Kamir, like down in Texas, you were like, okay, do you ever wonder, like at Boca Chica with Starship, how SpaceX just crapped out a bunch of industrial welders? Like there's a bunch of industrial welders there, all the heavy equipment, even the sub-assemblies, they just pop out of nowhere. You know why? Because heavy industry and heavy like welding, heavy fabrication, that's all over Texas. All over Texas. Why? Because they make oil rigs. Dude, you don't have to be an engineer in that industry. You make bank. I know guys down there that work on the rigs. They make a lot of money. A lot of money. Yeah, a lot of money. So I mean, it's not just Russia. The oil industry pays, dude. Our entire freaking civilization is built off of the oil industry. Without oil and metal, Without oil to lubricate metal, like, nothing works. Nothing works. We go back to the Stone Age. You know? So, but anyway, flipping it back over to the case of Roscosmos. Those modules are old, man. They're really old. I think that's why they were cracking so much. They were never really designed to be up there. Can't we use lubricants? Mad Cobra, lubricants are petroleum. Anything that's plastic is petroleum. Yeah, I mean, if it was up to me, would I try to, like, have them send more modules up? Yeah, that'd be really cool, but kind of sucked. Kind of sucks, man, seeing a project come to an end like that. But hey, it is what it is. This is most likely what the new station will look like. So this is a picture from Anatoly Zak of what the new orbital station could look like. I'm sure you can keep it up till 2030. Kem, how are we going to boost the station? How are we going to boost the station without Zvezda? There's no propulsion system, dude. I understand the reasons, but taking away Zvezda and Zarya is like taking away the service module from a capsule. It just kind of sucks. Like, I like working together, man. Working together is more fun. But hey, if that's not there, I think something tells me there are forces at work here that are beyond our control here. So it blows, dude. I like working with you guys. I like working with the Russians. I really do. But I mean, it is what it is. Progress is doing boosts nowadays. Could be a Starliner. It could be Cygnus. Yeah, I suppose. But hey, like, on the other hand, dudes, like, I don't think it's right to be like, no, you have to keep your modules at the ISS either. If that's the way it's got to be, I tip my cap. That's the way it's got to be. I get it. No problem. No, we own Zarya. But see, here's the thing, guys. We own it, but we don't operate it. We don't operate the module. I don't think we know how. I don't think Mission Control can operate that thing. The Russian Mission Control controls Zarya. So yeah, see, Cam, I'm with you on that one. We can't, if it breaks, we can't fix it. Let me see. Yeah, it's cool. Like I said, if that's the way it's got to be, dudes, that's the way it's got to be. I wish you the best. I really do. The U.S. should build a second gateway PPE for ISS backup. A PPE and a Halo module attached to the back of Node 1, that's an idea I can get behind. I mean, the Axiom modules are probably my guess for how they're going to fix that problem, TJ. Yeah, see, Cameron knows. I just hope we can cooperate more in space somehow, but they said they'll address that, in 2024, so, hey, it is what it is. Like I said, tip my cap, wish you guys the best in space, I really do. If that's how it's got to be, I get it. I'm a big boy, I'm not going to cry about it. It is what it is. I agree, TJ. Yeah, it's not a bad idea. Four years can change a lot. Yeah, that's right. That's right. Yeah, for sure. All right. Anyway, let's see what's going on over in China. Let's see what they're up to. So Andrew Jones is reporting here. The core module for China's space station is strongly rumored to be launching on April 29th. We should see the Long March 5B Y2 rocket to launch the 22-ton Tianhe spacecraft rolled out at Wenchang around Thursday. If so. Okay. It's okay to let your emotions out. No, I get it. That's the thing. It's just business. It's not personal. Yeah, look, you two. At least I know the folks at Roscosmos. At least, well, not. I don't know this for sure, but I'm pretty sure it's not personal. It's the same kind of crap that we have to deal with, which is why Atlas V can't use RD-180. It's not personal. It's just business. Unfortunately, it's not our business. It's just stupid. But hey, it is what it is. They might even try to work with China and dock a station together. Hey, if that's what you guys want to do. Yep, that's the Tianhe space station core. The Tianhe module is based off of the DOS module, so it's kind of like Zvezda, but it's also kind of not. It's their own. They've made a lot of modifications to it. It's bigger, for what it's worth. Well, April 29th. You know, they don't keep us in the loop, which kind of sucks, but. Yeah, it's important to note that Long March variant doesn't have any upper stage, and the Long March 5 core stage works a lot like the SLS core stage, in that it basically is like 98% of the way to orbit. It's in a decaying orbit, and last time it deorbited and landed out over Western Africa. I think it landed in Senegal somewhere. Yeah, not okay. Not okay. All station modules will launch on Long March 5B. Ugh. Is there a governing body for the ISS? Like, who makes the decisions? It's a joint venture between international partners, Snoodle. They come together and they figure out what's the best solution. So, the Americans, the Europeans, the Japanese, and the Russians. And the Canadians, excuse me. Forgot about you guys. Sorry. Sorry, bud. Sorry. Here. Here. For the Canadians, I'm sorry I forgot. I offer you a peace offering. Peace offering? Peace offering? I like you guys. You guys are alright. Peace offering? Nah, Sneaky, I needed this. It's only a little bit left, but I needed this because I just had chicken and waffles, man. I just got here, but I now feel that I was called with the offering. Well, I was mentioning all the international partners to the ISS, and I forgot Canada. So, as a peace offering, I present to you some organic maple syrup. Will you accept this gift? I have a hockey jersey too. I mean, you're not. Let's be real. That ain't a peace offering. This is. But I have a hockey jersey, okay? Was it made in Quebec? No, this is from Maine, which is kind of Canada. It's almost there. You need a Habs jersey? I would rather die than wear a Canadiens jersey. I have it's required, and this is not a Canada-America thing. This is a Montreal-Boston thing. Very different. Very, very different. What number is on the jersey? It's got no number on the back. It's just a Bruins jersey. Yep. Unrelated to that, do you have a P.O. box? No, not right now, Quantum. P.O. boxes are expensive in Boston, in like most things. Actually, I've been to Montreal, just on a side note. I've been to okay, rivalry aside, in Canadians, you can go piss off. I've been to Montreal many times. Beautiful city. Beautiful city. Really not full. Really nice folk. Really nice place. It's fun. Fun times. Been to the Formula One race up there a couple of times. Really great city. And I've been up there a couple of times with it when the Formula One race wasn't there. It's still awesome. It's a really nice place. Really beautiful city. Like, for real. And I'm not just saying that. What's sad is that I run into more people that don't know Maine is a state than people that think Maine is Canada. What? You ever been to Carnival in Montreal? No, never. I've been up there many times, Goonie, except I've been up there for Formula... Yeah. Have a bone. Yes, I will. Giving the dog a bone. Giving the dog a bone. Giving the dog a bone. Hey, Kem, look. It's a TU-160. Oh, wait, no, it's not. It's a bone, baby. Bone. What a Vulcan... Do not call that plane a Vulcan wannabe ever again. Ever. Like, don't you ever speak to me or my bone ever again. A Vulcan wannabe? I'm mad. I'm mad now. How dare you? How dare you? How dare you? How dare you? This is an infinitely cooler plane. Yes, it's not as imposing as a Vulcan, but and those aren't canards, they're winglets. The B-1 can fly without those, believe it or not. They put those winglets on there to reduce metal fatigue on the fuselage because of aerodynamic perturbations up front were making the plane do this when it was flying, and it fatigues the metal. That actually increases the life of the airframe. They're just aerodynamic winglets to help move the air over the fuselage better, like a wing fence on a wing. But also, don't you ever compare this to the Vulcan ever again. Don't you ever talk to me or my B-1 ever again, okay? You have spilled my macchiato! Ask Tess's opinion. Tess's opinion. Bro. All right, bro. All right.
Listen, Tranquility Base here. The Eagle has landed.
I was about to go on a rant about how the B-52 is the best strategic bomber ever made, but I've been interrupted. Agreed, there's nothing to compare. Kennard donated tip 50K. Those things are loud. What, B-1s or Vulcans? Vulcans are really loud. Yeah, see, Thomas, you get it. They put canards on planes that can hardly fly. Oh, I hate you. I hate you so much right now. How many different types of long-range strategic bombers is the U.S. currently operating? B-1, B-2, B-52, B-21. I think that's it. Hey, fellas. Hey, fellas, you want to know what the second best one is? You want to know what the second best strategic bomber is? You want to know? You want to know? You want to know? Boom. Get wrecked, nerds. Going full Karen. Yep. Boom. Boom. Destroyed. The Russian copy of a B-52? It's not a copy of a B-52. It's not a copy of a B-52. It's a copy of a B-29. Okay? God. Oh. Anyway, back over to space news. Let's see what else we got here. You're a copy of a B-29. Thank you. Best high altitude bomber is the WB-57. Hey, I think you guys are just mad because the sun set on the British Empire, okay? All right? Get over it. Okay? I think you guys are just mad. All right? I think you guys are just mad. No, seriously though, the British aviation is pretty awesome. You made some pretty good planes for British people. TJ, I always found that pretty interesting that both the U.S. and the Soviet Union and now Russia can trace their roots back to the B-29. Both strategic bombers, the B-52 and the Tu-95, can trace their roots right back to the B-29, which is always interesting to me. There's been a Spitfire variant with double props. Loud. I know about the Tupolev 4. Don't worry. Stalin went to Tupolev and said, build that. And Tupolev said, why? And he said, build it or you're dead. Okay. That's fair. I do like those pictures from Jared. Thomas, those are nice. As a Russian, I asked, one bomb on the Kremlin, they're completely mad there. Nesmus, I don't think we should do that anywhere, to be honest with you, man. Let's not. Let's not do that. No, let's not bomb anywhere. That's counterintuitive. Bombing is Bush League stuff, all right? You know why it's Bush League? Because the real Chads build stuff. I was about to say a bad word. Real Chads build things, okay? It takes skill. It takes time. It takes effort to make something. It takes 5 seconds of effort to destroy something. That's instant gratification, all right? Destroying things is the TikTok of physics, okay? The TikTok of physics. Lame. Building things, KSP of physics. True story. True story. Yep. More like Twitter? No. Toxic waste dumps? No. I mean, that's destroying the environment in some way or another. Where's all this bomber talk coming from? I don't know. Can we update the mission control GIF with Ingenuity's flight? Once I get some better quality footage, LQ2, I will. Yeah. No, seriously. I mean, don't get me wrong. There's some very finely engineered weapons, right? Like, I get that. I understand. But I think it takes true skill to build something. And, you know, like, there's... People engineer weapon systems all the time. But, like, I'm talking like making a skyscraper or something. You know? Novus, you can talk about that anytime, dude. Anyway, I got a couple more space news articles. And then we'll go from here. Let's see. Me not... Yeah, no, that's me going with the flow of chat. I always do that. It's fun. I mean, if you want me to be Mr. Stone Cold over here and go through all the articles real fast, I can do that. See my last. What do you think is better, Stratolaunch or White Knight? I like Stratolaunch. You know why? Because it's bigger. Did you hear what Mimi said? Did you hear what Mimi said in the presser this afternoon? I don't care. My job is to just want it to go as far and as fast as we can. I like that. I like that mentality. Anybody notice that everybody at JPL has an almost American accent? And that's not, it's not meant to be anything weird. It's just everyone has an, I find that it's like an almost American accent. Don't get me wrong, they're Americans, I get it. They emigrated from somewhere else, that's fine. It's just, I always notice that everybody has an almost American. I like that, that's cool. People from all over, man. Doing science, creating things. It's good stuff. You see Bob, though? Bob, what do you think we're going to do for the party? I think you should take your leadership role on that one. You're great at leading people. Maybe you can lead the party plans too. It's just like, yeah, okay. Bob's that kind of boss. All right, cool. So no party then. Got it. That was a nice way of saying no. You do that on your own time. Yeah, Draco, for sure. Absolutely. And dude, that's fine. That's totally cool, you know? Yeah, Mayor, it's like 95% of the way there. Yeah, Tom, you know you'd her. Yeah, Laura, Mimi, you're very good at leadership. Maybe you should use your leadership skills for the party. Oh, you're that kind of boss. Got it. Yeah, okay. All right, fellas, I'm going to turn on the Starship thing real quick. The Starship vid. I got to use the restroom real fast. I'll be back in a moment. Actually, you know what? I want to watch that, so. I'll be right back 1 second. Just got to use the restroom real quick. Yeah, I mean, drummer, there is that. But I'll be right back. Got to pee.
Discovery, go at throttle up.
What a day. Did Chair keep you guys entertained? Artemis 3 engine section. Oh boy. Very nice. Chair's still here. He's just taking a back seat to me. He even gifted a sub. Gifted a sub to Chair. Okay. Yeah. Chair's the only one that's allowed to backseat me. Yep. Mm-hmm. Okay, so here's a big one. You guys want to get confused from this next space news? Here's one. Check this out. What do you make of this? Project Kessler. So, Amazon signed with United Launch Alliance for 9 Atlas V launches of its Project Kuiper internet satellites. Jeff Bezos. We're determined to make affordable broadband a reality for customers and communities around the world. It brings up some interesting questions, and this is why this is a real humdinger. It brings up a lot of interesting questions here. So, first of all, Amazon. Okay, so there's been a lot of talk about this over on Twitter from a lot of different folks thus far. So here, let's go back over here. Amazon declined to comment on the value of the launch contract, as well as how many Kuiper satellites will launch on each mission, or what version the Atlas V rocket they'll use. Additionally, Amazon emphasized that Project Kuiper will need multiple launch vehicles and launch partners to deploy the constellation on time. Leaving the door open for future deals with the likes of SpaceX, Blorgen, and Ariane. I'm pretty sure Geeson, yeah. Yeah, Xeon, pretty much. We'll need multiple launch vehicles and launch partners to deploy the constellation on time. So, it very much seems like they're going to use... So, okay, a lot of people are reading into this. And they seem to be reading into it like their rocket isn't ready, right? That may be the case, but if you'll allow me to speculate, because everybody else is speculating on this, so I'm going to throw my hat into the ring, okay? Keep in mind, this is just a theory. I don't know if this is a thing for sure. So, the other day, NPO Energomash, who makes Atlas V's first stage engine, the RD-180, reported that the last batch of RD-180s have been shipped out from NPO Energomash to be received by ULA in Decatur, Alabama, okay, for use for building Atlas V's. Now, a couple of keen-eyed people noticed that the amount of NPO Energomash RD-180s that they were delivering was not correlative to the amount of defense missions that the Space Force has with Atlas V. Now, why is that important? Well, in 2014, because of Rule 8 reasons, ULA was basically told to not use Russian engines to launch stuff into space, right? They were told not to do that for reasons. If you want to go look into it, go ahead. Now, Atlas V is on its way out, just like Delta IV. And ULA can't use it to launch defense missions. So that leaves ULA inadvertently with a lot of extra, well, inventory for Atlas V. Right? So I can tend to say that this isn't necessarily because it isn't necessarily because you know, their vehicles aren't ready. All right? But it has much more to do with them basically competing with Starlink. Long story short, that's what it has to do with. Okay? I don't know, drummer. So, what most likely, because Atlas V isn't really competitive, Tori Bruno, exactly, Cirrus, you probably cut them a deal to launch on Atlas V so they could start getting their constellation built and then really put it to the test when Vulcan and New Glenn start flying. Basically. That's where it's at. I'm pretty sure. I'm pretty sure that's what's going on. So it's not necessarily, oh, our launch vehicle isn't finished, so we'll use Atlas V's. It's, you know, we can launch stuff earlier into space if we use the leftover Atlas V's that ULA has. I'm fairly confident that that's what's going on. Everybody seems to put it as like, oh, they must be having problems with Vulcan. I assure you that Tori Bruno is not having any problems with Vulcan. I don't speak for the man and I don't speak for ULA, but does ULA seem like the kind of company that would? Hell no. Not a chance. If there were any production bottlenecks anywhere, this guy would be on it like flies on dung. All right? There's no way he would nip that right in the butt real quick. Tori Bruno has some clientele for that he launches stuff for that has very deep pockets. Don't disappoint. Yeah, make sure it gets done. Am I right? So I'm pretty sure that they took the leftover Atlas V's that they had and the leftover engines that they had and cut them a pretty good deal. That's why they're not disclosing the price, because it's probably way below. But you gotta do something with those things. Bezos preferred to pay a little more and then fly on Atlas than using Falcon 9 or Soyuz. But then they said that they would work with Arianespace, therefore it's possible that they could use Soyuz as well. My space shuttle flies like a brick. What do? It's supposed to do that, S. I think ULA bottleneck is more than likely payloads. I agree, Geeson. Yep. Yeah, I mean they emphasizing deploying Project Kuiper on time. What's the rush? Well, the rush is to be competitive in the market. I'm pretty damn sure they want to compete with Starlink, which is fine. Just got here. What we talking about? Amazon bought 9 Atlas V launches, Reagan, from ULA to start deploying their internet satellite constellation. 9 Atlas V launches. I'm also pretty sure that these will launch on 552, which is pretty cool. Nice. GSC-2 tank is at the launch pad for integration with the fuel farm. Cool, cool, cool. So yeah, very interesting what's going on. Very interesting. That's definitely... It's definitely weird seeing an Atlas V with a Amazon logo on it. That's not something I ever thought I'd see in my lifetime. That's just weird. 9 Atlas V launches? That's like 45 launches. Yeah. That's exactly the same. That's how that works, sure. Yeah, Amazon suborbital delivery. I mean, Jeff needs to get on that Earth-to-Earth game so I can get, you know, like Chinese food fresh from China, man. That'd be really good. Why not New Glenn? New Glenn is still being deployed, Morzen, and I think that Project Kuiper needs to get off the ground figuratively and literally to gain market share with internet satellite constellations because it's competing with Starlink. Starlink's way ahead, way out of the gates. Amazon goes orbital before Blue. That'd be a little weird. Alright, see, Mike weighed in on this. Let's see. Bizarre lack of BE4 from a project backed by Jeff Bezos, but a much-needed commercial win for ULA. The lack of New Glenn is not surprising. That rocket is not launching anytime soon. The lack of Vulcan is a bit shocking, and I wonder if it is a sign of any problems with the Vulcan program. Yeah, see, I don't think that's the case. Yeah, Astro, you like that? Do you know what the orbits are compared to Starlink? They're higher. They're, I think, 800 kilometers up. No, Vanguard, not at all. Is it, Kim, it's got to be like 600 to 800 or something. Yeah, see, I was reading what Mike said more. Surely Bezos would not be paying more to fly on a rocket that does not use his engine if it was going to be ready in time. Perhaps there's something else to this, like an extra stockpile of RD-180s. That's what I'm putting my money on. ULA was building up a stockpile of RD-180s in case Vulcan was not ready in time for NSSL Phase 2. If the reason is that the stockpile will not be needed for NSSL... No, I don't think it was for to building up in case Vulcan wasn't ready. I'm fairly confident that it's because they had extras, but who knows? Interesting news nonetheless. 590 to 630. Thanks, Starfleet. Definitely interesting, that's for sure. Alright, this next bit's coming from space.com here. Russia joins China's mission to sample an asteroid and study a comet. The two nations are becoming regular space partners. Oh boy. China selected a Russian science payload to fly on an upcoming mission to sample a near-Earth asteroid and then later visit a main belt comet. China is aiming to launch the ambitious mission around 2024. First, it will collect samples from the small near-Earth asteroid Camouflage. No, it's Kamoa Lewa. Then the spacecraft will return to Earth to deliver the samples and use the planet's gravity to send the spacecraft towards the main asteroid belt to the orbit of Comet 133P. Cool. Russia will now join the mission with instruments built by the Space Research Institute and the Russian Academy of Sciences. The payload was selected following a 2019 call for proposals by CNSA, China's national space program. The spacecraft, tentatively named after Zheng He, a famous Chinese naval explorer in the early 1400s, will carry a range of imaging, multispectral and spectrometer cameras, as well as a radar, a magnetometer, and payloads for detecting a range of particles. Cool. Neat. Yeah, I'm good. I don't need any newsletter. Thank you, space.com, for nothing. That's just weird, Thomas. I don't like that at all. Mike is correct with that statement. They built a stockpile of RD-180s in case Vulcan had a problem, which is why Atlas V can be used as a backup for NSSL. That's why ULA didn't bid on some of the GPS missions, and SpaceX got them by default, so they could stay in line with congressional limits. That makes sense. Yeah, okay, cool. All right. Let's see what else we got. So, China has a lot of missions coming up. Yeah, man, that's cool. Stop dropping stages on people and I'll get excited about them. You know, like, Cam, I still have a really, really deep problem with that, dude. I really don't like that. You gotta stop that stuff. Like now.
Discovery, go at throttle up.
AFD, 9-month resub. United Launch Alliance has recently made pad upgrades to Space Launch Complex 6 at Vandenberg ahead of the upcoming Delta IV Heavy launch of the NRL-82 mission for the National Reconnaissance Office, scheduled for April 26th. That dodged a bullet there. Yeah, I mean, there is that too, but yeah, we'll keep it space oriented. Joe's like, I know this one. All right, Joe, let's see what we got. Let's dig in. So this article's coming from NASA Spaceflight. Joe wrote it, in chat, and then Chris G. See what they said. After rolling to the pad in November 2019, the flight reached its first launch attempt on August 27, 2020. This is the NRL-44 mission. This attempt ended without fueling of the vehicle after a heater and pneumatic issue forced controllers to scrub the launch. Second attempt was originally set for August 28th before being pushed to the 29th, where engineers needed more time to solve the pneumatics issue. The second attempt saw Delta IV Heavy fueled before a temperature issue on the rocket forced the teams to push into the launch window that day. Push out of the launch window that day? The issue was eventually resolved and teams cleared the rocket for launch. The engine sequence began at T-7 seconds with the ignition of the starboard booster's RS-68A engine. However, an automatic abort was triggered at T-3 seconds before the core and port RS-68's engines could start. Aborts after the engine ignition of the RS-68 require a minimum recycle of 7 days. The recycle involves engine inspections, engine drying, and leak checks, and replacement of the engine start ordnance devices. Yep. Some of these operations, especially the drying of the engines, are similar to the RS-25s. As seen this year, once the RS-25s are ignited, an extensive 3-week-long recycle period takes place, most of which is dedicated to engine drying and inspections. The drying process has largely to do with the engine's use of liquid hydrogen and liquid oxygen. Yeah, liquid oxygen is ironically, it's very, 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 very bad for rocket engines. I should say it like this. It's very bad to sit in rocket engines. This is why, if you ever noticed, like sometimes when rockets shut off, they puff some smoke out the bottom. They're trying to purge the lines, trying to dry the engines using the pumps. I think. I'm pretty sure that's how it works. I'd have to ask Rocket Guy to be 100% clear. But some engines do require the need to be dried. You have to go in there and you have to get all the liquid oxygen out. Or wherever the liquid oxygen stays, you have to make it out of something that's not corrosive or prone to oxidization, like titanium or something. I mean, amongst other things. Yeah, turns out that oxygen oxidizes things really well.
My Rafflecopter goes swah, 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 swah.
Yeah. It was a weird pause, so I decided to put something there. Yeah. Yep. Yep. Oh, you're wondering what that was? Well, that was NASA's footage. That was NASA's microphone footage from the Ingenuity flight. They recorded it, and this is what it sounded. 2021, colorized. Drop the beat, 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 beat. Rolling Stone. All right. However, the engines on Delta IV Heavy were not responsible for the abort. That was the ground system, specifically a terminal countdown sequencer rack that detected a high volumetric flow rate pressure regulator that did not open. Further investigation revealed that the regulator failure after a diaphragm tore on the ground support equipment. Oh god, it's like mechanical fuel pumps, the damn diaphragm. You look like a whack, a whack, a whack, a whack. I love my audio colorized, that's right. I'll have to check that in a second, Bandit. All 3 regulators were replaced, and after fixing the issue, setting another target date, ULA then encountered a swing arm retraction issue and 2 scrubs due to pre-launch weather and a hydraulics issue on the mobile service tower. This all led to an attempt on September 30th, 2020, in which additional anomalies were seen with some of Slick 37B's swing arms. September 30th ultimately ended in a late count hold just milliseconds prior to the T-minus 7 seconds start of the RS-68A ignition. Oh boy. I want to... Joe, where's the part about the upgrades? GoQuest is headed to the Crew 2 booster recovery zone. Cool. Milliseconds. Yep. Freudian slips, man. So it looks like ULA... It looks like what they did at Slick 6, where the... which one is this? NRL 82, which is the 4th to last Delta 4 to fly, received a bunch of upgrades. That Slick 6 right there, of course, out in California at Vandenberg, was originally started as a Titan 3 Gemini manned orbiting laboratory launch pad, and then that got canned for the Apollo program in 67, and then the pad laid unfinished until the late 70s when the Air Force wanted to get on board with the Space Shuttle program, and then they retooled the entire pad for the Space Shuttle. And then after Challenger happened, they promptly abandoned it. And then it was used for Athena missiles in the early 2000s, or in the late 90s, and then switched to Delta 4 in the early 2000s. SN-15 flight TFRs removed for 420 and added for 421. Okay. So yeah. And it has basically this launch and one more left, and then that's it. And then I'm not sure what's going to happen with it. Removed for both 420 and 421. 421 was pulled. If the shuttle ever did become operational at Slick 6, would it have been only Discovery that launched from there because it was only for the Air Force? Squishin, you know what? I don't know. I don't know if NASA ever planned, or the Air Force ever planned on procuring more shuttles. The flight TFR for the 22nd remains. Swishio, hello. Finally found some time. School is packed with tests these days. Good. Do the tests. I'll be here when you get back. Dead Crew with a 7-month resub. Huh. Okay, so Squishin, where I'm going to is that, well, Discovery was set to go to the Air Force in early 1980. Well, actually, in the summer of 1986, Discovery was going to go to the Air Force, and the Air Force. Well, actually, you know what? Let's do a quick thing here, real fast. Let's see what we got. So, if we go over and look at Slick 6 at Vandenberg, there, you can see all the former shuttle hardware that's supposed to go with it. Like that building and that building. This was basically all for the space shuttle. That building right there was for the orbiter itself. That's the orbiter processing bay. And then over here, I believe, is a solid rocket motor and external tank facility, I think. Don't quote me on that one. I'm fairly confident that this one is for the SRBs. The reason I can tell it's for the SRBs is because it's got a train track going to it. Train track, you need the SRBs. The SRBs are delivered by train, right? So there's a spur line right here that tees off the... Oh, it's a switchback. It's a switchback that tees off of the Amtrak line that's out here. There should be another train track. Yep. Yep, see? That railroad line was undoubtedly made for SRBs, and SRBs were designed to be processed here and then moved to the pad in segments. Now, Over here is the external tank process. It was the external tank processing area. This is where they kept the ETs. You want to know how I can tell? The road. The road's a dead giveaway. So it's very clear where the road is built up for heavier stuff, for moving around shuttle parts and now Delta IV parts. The sides of the road were planed out for the space shuttle and the external tank, right? So you could tell, I mean, it's not one of these small little dirt paths here. This was made for the shuttle to go around. That's for the external tank, if I had to guess. And then if you follow this, it leads right up to the shuttle processing area. And it's important to note that that looks like it's big enough for one orbiter. So orbiter, SRBs, external tank. Once again, this is guesswork. I don't know. I don't know what that pad is. They're building something new out there. So if I had to put 2 and 2 together, right, you could see that the flame trench right here, SRB, left SRB, right SRB, shuttle engines, right? If I had to put my hat into the ring, I would have said that the Air Force initially would have just used one, would have just used Discovery for their missions. The other thing I can do to kind of figure that out is if you go and look at Kennedy Space Center. All right, so we can extrapolate some information by going over to Kennedy and looking. That pad is Slick 8. Cool. The external tank building will be Relativity Space's launch pad. Cool. Yeah, the S-Master, they might. So, another thing to look at here is if we go look at KSC. All right? So, now, if you look, initially at the beginning of the shuttle program, they built 2 orbiter processing facilities, OPF-1 and OPF-2. Now, why would they do that if they planned on having, well, if Discovery was going to go to the Air Force, why would they do that if they planned on operating Columbia, Challenger, and Atlantis, right? You have 3 orbiters. Why build 2 OPFs, right? But then if you think a little bit further, Discovery ended up not going to the Air Force because of Challenger, and they ended up building a third orbiter processing facility for a fleet of 4 orbiters. Columbia, Discovery, Atlantis, and Endeavour, right? So it's very clear that by this indication, you know, for shuttle flights, they would have a shuttle being integrated and 2 shuttles in processing, right? So if NASA was only planning on having 2 OPFs, which means that they were going to have 3 shuttles in the fleet, the Air Force would only have 1. But once again, we never know. You don't know how the contract was structured. Maybe if the Air Force wanted another one, they could have procured another one. I'm sure they would have if they saw the need for it. But at least initially, it seems like NASA was going to operate with Columbia, Challenger, and Atlantis, and Discovery was going to go do the Air Force missions. That's just, once again, that's just some basic logic chains right there. That's right, Sebi. Didn't they also want to turn Enterprise into a fully operational shuttle? Well, they ended up doing that with Challenger LQ2 instead. It was found that instead of taking Enterprise apart and making it into an orbiter, they just took Challenger, which was a bare-bones shuttle chassis with no parts installed. They took that and made that an orbiter instead. Because instead of taking apart Enterprise and then refitting it into an orbiter, they just skipped that step, the whole disassembly step, and then put Challenger together, which started as a structural, it was the STA for the shuttle program, the structural test article. Why is there an outline of a shuttle on the ground looking down by the VAB? What do you mean, Need? Right there? So this is a little park right here between the press site and NASA's Operations and Support Building 2, or OSB-2. OSB is where all the engineers for, well, now SLS will be. All the engineers for SLS are there. There's OSB-1 over here. OSB-2 is right there. So Operations and Support, and then the press site is right here. They put that there because they put a little park there. It's cool, man. I've seen it. It's really neat. That thing is huge. That shuttle outline is quite big. Yeah, see, 500 feet. I've been in that building. Yep, so have I, dude. Yeah, I've walked around in OSB-2. They got a nice engine sitting right in the front desk. It's pretty cool. Yeah, I think it's cool, GNAC. Lots of cubicles. I mean, it's just an office building. Does Google still show a space shuttle model on pad 39A in 3D mode? Maybe. But yeah, that's cool that they're upgrading Slick 6 to make Delta 4, you know, reliable, but it's on its way out, which really does suck. But anyway, we're going to switch from looking at Florida and Vandenberg down over to Boca Chica, and let's see what's going on down there. This video also, just like the last article, is coming from NASA Spaceflight. Mary, Boca Chica Gill, is the woman that filmed all this. She's the one that gives us all this footage, and NASA Spaceflight is the one that cuts it up. So be sure to support them where applicable. Yeah, Snake, that's right. There's a lot of parking lots, just like the Minecraft server. That's right. It's just a crane moving one of the jigs. And we're sped up. Okay. GSE-3 ground support equipment tank 3 is on the left. And then the weird load cell is on the right. Still can't figure out exactly what that's for, but I mean, a lot of folks have been saying aerodynamic loads, so that, I mean, that sounds right. Yeah, Wolfie, I think that's what it's for, yeah. Yeah, they moved GSE-2 to the launch site. It's about to be integrated. Look at all these dang FIRDs. Look at all these dang FIRDs everywhere. Look at that. FIRDs. Toyota. Ew. Ugh. Looks like a scrapyard. Toothless, I don't get junkyard from this. You know what I get from looking at outside pictures of Boca Chica? Distillery. Looks like a brewery.
Tranquility Base here. The Eagle has landed.
Crawler crane thief. Really, Jack? That's funny. And these Fords are in the junkyard. That Toyota would really like a top. Did you see the Top Gear episode? The Top Gear episode had Toyota tractors more reliable than everybody else. Did you see it? They dropped it off of a building. The Toyota dropped it off of a building. Yeah, whatever. Yeah, whatever. Let's see that Hilux go up against the 79 F100. You can't kill it. It is indestructible. It's like the T1000. I don't care about the Toyota reliability. No, no, no. A 79 would beat the trash out of that thing. No, I don't want to hear excuses.
Water with sugar. Listen, monkey boy, compared to your little Ford truck, or little Toyota truck, my Ford is at the top of the evolutionary ladder. So can it, alright? You ever see people pick on a Ford? You ever see a Ford try to get even?
Wow, this is irritating. Bye. Alright, see you later. Oh, look. Another Ferd. He'll probably be back. It's alright. I don't know, S. You can't please everybody, dude. If I got really preoccupied with every little thing that was said in chat, you know, I would have gone insane a long time ago. Fortunately for you, you're dealing with someone that does not care what you think. Do you think I would do that? You think I would talk like that? So that explains why you're insane. I don't know, man. Just don't really care what people think, to be honest with you. Like, that's the honest truth. I'm really surprised they're not putting up SN15 tomorrow. Must have had some issues with that Raptor integration, Tessa, because they pulled the TFRs for the 20th and the 21st. TFR is on the 22nd, which means that they must have had a little bit of a hiccup somewhere. What was that historical marker for? I'm not 100% sure. Oh no. Oh, the floodplain flooded. Go figure, I know. Well, yeah, OKT, dude, Starship is big. It's very big. There's some pieces of it over there. Your boos mean nothing. I've seen what makes you cheer, public. Will they clear the SN11 scrap? It's a priority, Mr. Failures, for sure. This is awkward. Did they give reports on when these Starship rockets fail their landings? They have to. They have to file a report, an accident report with the FAA, GNAC. They have to. You know, a lot of folks say that that's a stupid idea. I honestly think, you know, if SpaceX wants to put people on this someday, you're gonna have to play by the FAA's rules, dude. It'd be good to document all this. In fact, I would say that, you know, documenting it right now would make Earth-to-Earth air travel or Earth-to-Earth space travel actually more viable in the long run. It's stuff like this, well-documented phenomenon that happens with these rockets that will make that a viable venture. Part of the reason why the FAA is so strict is because them being strict in the past got us air travel as cheap as it is now. Seriously, look up the de Havilland Mosquito. Perfect example. Perfect example. The MD-11s with their hydraulic issues, part of them getting, like, the National Transportation Safety Board and the FAA doing these accident investigations that'll actually end up making it safer. So if SpaceX wants to take like Earth-to-Earth stuff really seriously, you play ball with the FAA, which is exactly what they've been doing. It makes perfect sense, dude. Like, a lot of people get up the FAA's tailpipe about this, and don't get me wrong, I won't miss an opportunity to bash the government and call them incompetent. I won't miss an opportunity to do that, but that's not what's going on in this case, dude. In this case, the engineering denotes the policy and not vice versa, you know? Yeah, not the Mosquito. Yeah, sorry. Mosquito is a god tier airplane, and that plane could literally do no wrong. The Comet with the square windows. I mean, Tesla. It's like we've talked about. That plane sacrificed itself to make airline travel safer, and I'm guessing that down the line, some starships will sacrifice themselves to make Earth-to-Earth travel safer as well. Hopefully, SpaceX does not go the way of de Havilland, but that would really suck. But also, we can talk about God's gift to aviation, that de Havilland Mosquito, which is quite possibly the most chattiest plane of all time. Stealth plane, World War II, stealth plane, fastest plane, could almost make transonic with propeller, you know, because Spitfires are good, man. Like, I'll be real with you, Spitfires are great planes. Spitfires are great planes. They have that great Rolls-Royce Merlin engine in them. They're fantastic fighters, all right? But you know what's better than having one Merlin engine? Having two Merlin engines. Yeah. Yeah. You know what's better than having two Merlin engines? Having four Merlin engines. Yeah. Yeah. See what I'm getting at here? Yeah. No, the Mosquito is one of my all-time favorite World War II planes. It's right up there with the P-47. I'm a P-47, P-38, and de Havilland Mosquito kind of guy. Also, Focke-Wulf 190. Yeah, that's a great plane. What about 9 Merlin engines? I can get behind that. Sure, why not? Yeah, it was made of wood. That's right. It was stealth. It couldn't pick it up on radar. It had the radar signature of a bird. Seriously. It was made out of wood. You couldn't see it. And the thing has 2 Spitfire engines in it. Each one of those engines makes like 1,000 horsepower. That's ridiculous, even for a prop engine. That's nuts. 81 Merlin engines? I mean, 27 is probably, I think, the most amount of Merlin engines I'd want without something going terribly wrong.
Discovery, go at throttle.
Hey, Flight Sim, 5-month resub. Thanks, man. I said 5-month resub. I meant gifted 5 subs. Sorry, my code is not working correctly. Flight, thanks for the 5 subs. I appreciate it. 5-month resub. I'm going to reboot. Give me 1 second. Okay, I'm back. Anyway, sorry, I had to reboot. Yeah. Pharaoh, how'd you know? Does current radar catch a wood-made plane? No. Supercraft. Wood doesn't reflect anything. It doesn't reflect radar. I mean, modern radar could probably pick it up, but the radar signature would be small. But I'm not really too well versed in radar, to be honest with you, so I don't know for sure. End of the war, the Merlins were mental. 75 to 80 brake horsepower per liter from back then. Yeah, I know. It's frankly absurd. It's like the Raptor engine of its time. Seriously. Ah. So there's a Ford and a porta potty right there next to the guard shack. That's really weird. Thomas, so Raptor 54 went to the pad, then was brought back to the build area and then was installed on SN15 last night. What's that, J-Dude? Oh, whoops. Nah, actually, I like those old early 90s Chevys. Those are actually pretty cool. They'll become classics someday, which is kind of funny. Right now, square bodies are the Chevy truck you want. From like 1972 to like 1987. Those are the ones you want. Colorado? I mean, that's fine if you want a smaller truck. It did, Flykin. Yeah, that's the HLS mock-up. Yeah. That's been there for a while, dude, but yeah, I mean, it's still cool. So there's the orbital launch mount right there. I know, Brim. One in good condition. Price has gone up like 1,000% over the last 5 years, which is crazy. I remember when I bought the 59, those trucks went for nothing. Oh, nice, Thomas. SpaceX fire truck. Okay, all right. Guys, I have a weird question, okay? Does anybody else really like the sound of tires going over gravel? Like that? You know, because they're driving on, I mean, it's driving on a concrete road right now, or an asphalt road, but it's got, like, pebbles on it. All right, cool. Weird question. Because that, you hear that noise? I love that noise. Yes? All right, okay, cool. All right, cool. Not just me. All right, sweet. They're putting in sidewalks, actually. See? You see the forms for the concrete sidewalk right there? All right, cool. Just making sure. Sound of a crawler going over gravel. Yeah, Novus, you know what? Well, it's not gravel. It's Tennessee River Rock. But also, I'm with you on that one. Dang this smooth road surface. The crunchy noise of walking through snow. Yeah, yep. Okay, I get you. It's Tennessee River Rocks. Hang on a minute. No, these aren't some rocks I just went and picked up at the beach. That noise there. Stop! Yeah, the guy that invented the pet rock gene act, the guy made $1 million. Man, so those iron huts right there were installed at the tracking station. I don't remember those being there last time. Yeah, that's right. I'm like Jet Li in Lethal Weapon. How many channels did they get with that? Yes. He's playing Factorio, Cities, Kerbal. What the hell? What's that doing there? No, not the Dodge, this. I like that Dodge, actually. That's nice. Heavy-duty Ram right there. But look at, there's an old thrust puck right there. Yeah, Ford's okay. It's only an F-150. It's all right. Actually, you guys want to know something crazy? SpaceX bought these things wholesale from NASA. They were used in a ground tracking station at Cape Canaveral Air Force Station, and they bought them and moved them here. Yep. Do you still think they could get BN2 by the end of April? Because I don't think any parts have been stacked. They've sleeved the engine sections, Wii Sports. It'll come together a lot faster than you think. I'm not sure by the end of April, but definitely by the end of May. Provided that everything goes right with these hops and whatnot. I mean, SpaceX's timelines are constantly in flux, fellas. Last, please. What's a thrust puck? It's what Raptor engines mount to on Starship. That's a really, really old one. I think that's a junk pile, Flecken, if I had to guess. That's a trailer. It's a nice trailer. Yeah, they have a huge solar farm, Flecken, that's powering the launch pad. I mean, that's the grid for the local area. And this is the, what's it called? Prancing Pony. Man, they expanded the heck out of that. Elon going green. Elon is the green movement, Flankin. Jeez. What is this place? Ken, this is the, this is a drive-by filming, I guess, of Boca Chica and the surrounding areas. You can see South Padre Island over there. Now this road heads to Boca Chica Village right here. And you should see the build site. There's the tracking station, and there's the build site. Yeah, Canuck, that's right. None of the pictures on Google Earth Animal are updated. That's the observation area for when the stuff goes to launch. There's a huge observation deck right there. I didn't know they had a restaurant. Yeah, the restaurant is made out of the fins from Mark 1. True story. Is that a Supra? No. There's some TEUs right there. All right. What do we got here? These look like boom extensions. There's 3 boom extensions right here, and then right there is a derrick. See that? There's a derrick extension right there. This is a derrick extension for pull. Actually, those look like the tops of the jib masts because it has the pulleys. I think those are the jibs. This could be jib parts. It's hard to say. Yeah. I know they're big Chungus parts. I know. What's that? There's a gooseneck trailer. There's a Super Duty right there. Wonder what that bogey is for. Huh. There's another Super Duty. There's that thing that bolts into the, that thing that they made that bolts into the SPMTs. There's some I-beams. There's a couple of TEUs over there. These are 22,000 pound counterweights right there. 10 metric tons by Liebherr. Liebherr because it's metric. So 10,000 kilograms is 22,000 pounds. So yeah, 10 ton weights. Interesting, Tessa. All right. For the end of the crane boom bin when building, it stops its nose from diving into the ground. Yep. All right. Well, that's the footage from NSF, and I don't think NSF covered the. I don't think NSF covered the GSE move to the pad, but that they did do that. And then I have one more video coming from them. Chronologically, this is behind the one that we just watched, but it's okay. Let's go over here. There's your Toyota. Okay, all right. Single cab short bed Hilux, I can get behind that. Or it's a Tacoma, it would be a Tacoma. They didn't cover it, but Mary was out there. Yep. Ah, there we go. There's the Chad Ford actually doing work. Unlike the Toyota. I'm not sure what that guy's up to in there. I mean, he's either plasma cutting or acetylene torching something. There's some air gas in there. You can tell because of the way it is. Could be grinding down a weld. Yep. Ah, yes. The egg. What is air gas? Air gas is a pneumatic gas supplier. That's most likely nitrogen. It's most likely nitrogen gas. Or it could be for welders. It could be argon for a MIG welder. Could be a bunch of different things. Let me actually go look. So that truck has a reefer on it, so it's refrigerated. I mean, it also says refrigerated on the side. You can usually tell what the truck is hauling because it'll have it marked on these diamonds right here on the side. I think that's empty. This one, whatever it was refrigerated, so it's either nitrogen or it could be oxygen too, but I'm gonna guess nitrogen. Air gas does all kinds of stuff, Vin. The medical industry uses a lot of liquid oxygen. That's part of the reason why liquid oxygen is so inexpensive. What for, though? What does the medical industry use it for? Cooling things, if I remember right, but I could be wrong. I mean, I'm not 100% sure. I know they do use it. There's a lot of medical equipment that uses that stuff. There's one in Salem. Right on. Yeah, Pure O2 for patients. Yeah. Yeah, medical uses a lot of cryogenic stuff, to be honest with you. Yeah, they're building up a big dirt berm there between the orbital pad and the landing pad. Air gas also makes anesthesia gases, so nitrous. Good to know. It's the boom barrier. Yep. What these berms have devised to do, see how it's angled? So if the thing lands over here where this JCB bulldozer is, right? Actually, that's a front end loader, but whatever. I only say it because I know someone's gonna give me crap for it. If Starship lands right here and it blows up, the explosion will get vectored up. That's what it's there for. It's a deflector. It's a blast deflector. That's what that berm is for. That's a front end loader. It's not a bulldozer. And the thing that was compacting down the berm is an excavator. Now that right there is a Fagioli telescoping crane. Actually, Fagioli's the operator. That's a telescoping crane right there. And this sucker right here is a Liebherr 11350, which is one of the biggest cranes around. It's not the biggest, but it's one of the biggest. I mean, I know I've been pointing out the trucks the entire time. Haha, I get it. Seriously, look at the truck comparatively to the crane. And the truck's in the foreground. Yeah, the truck's about, say, 100 feet, about 30 meters in front of the crane in this shot. The crane in the foreground. That's how big some of this equipment is. It's huge. The house and the operator box is the size of the cab. Yeah, see, they're using this crane to move the pieces into place and assemble them. These pieces, if I'm looking at this right, that's the start of the derrick on the crane. If you notice, this is attached to the top pin right there. Now, you can't see it, but there's a bottom pin right here as well. The top pin right here that this is attached to is for what's called the derrick. The derrick is connected to the mast. The mast is this thing that says Fagioli on it right there. That's the mast. The mast pulls the derrick, and the derrick can control the boom with pulleys. This is the derrick. I don't know if it's named derrick, but I mean, it is a derrick. This thing won't be as tall as the main boom when they go to assemble it. Now look at the people on that thing too. It's freaking huge. If each of those counterweights weigh 10 tons, yeah, each of those counterweights do weigh 10 tons. Those are the same things. This is a Liebherr crane as well. The counterweights are actually swappable with the blue crane as well. They're the same thing. Cranes go together like Lego kits. The counterweights go together like Lego kits. The lattice structures, the derrick goes together like a Lego. The boom, everything. It's just a big. It's big. It's Lego Technic for grown-ups. Seriously. You see, there's pins right here, and they'll use this crane and they'll lift the pieces into place and they'll attach the pins. They'll attach the top ones first, and then the crane will lift the derrick, and the two pieces will go like this, and then they'll attach the bottom pins, and then they just rinse and repeat until they can move the derrick up into place. They use the mast to build the crane, which is pretty crazy. And then I'm willing to guess that this big freaking glass of water right here, that's the boom. Now look at the difference between the boom and the derrick. The boom is what's carrying the load most of the time. That thing is huge. Look at the size of the pin. The pin on that freaking boom is the size of this truck tire. But just don't mix it with mega blocks. No. Oh. Excavator, Bobcat. Bobcats are little mini front end loaders. Those things are really cool. Super useful. Did we ever get an explanation for the SN11 failure? Yeah. Crutches, how much do you know about cars? Because I can explain it better that way. More about rockets than cars. Okay. Do you know enough about cars to know that if you put your foot on the gas pedal and pushed it to the floor and then started the car, a bad thing is most likely going to happen? That's how you hard start an internal combustion engine. SpaceX did the rocket equivalent of that. Yeah. The rocket equivalent of that. Yeah. And if you know anything about rockets, when they fail spectacularly, right? An internal combustion engine, you shoot a rod out the side of the block if something goes wrong, right? A rocket engine, when it hard starts, it blows the entire back of the vehicle up, and that's exactly what happened. So it's not so much too much fuel, Quantum. What happened is they had a methane leak. So oxygen and nitrogen were getting into the methane lines. So when they went to thermally condition the engine, all the methane leaked out, and then when they went to start it, the engine wasn't thermally conditioned correctly, and they shock froze the thing, and it just failed. It failed miserably. It just popped. You don't set the right operating conditions for a car engine, it doesn't work as well and could potentially break. You don't set the right conditions for a rocket engine because it's very, 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 very over-engineered. It'll explode. Yeah, and that's exactly what happened. It exploded with force enough to shear off the entire back of the vehicle, methane and oxidizer tank. So yeah, a hard start is what happened. It's hard starting a rocket engine. It's not good for it. Very bad for it, actually. Yep. See, check it out. So the thing that says roll lift on it, that's the mast. The smaller one of these is the derrick, and then the big one is the boom. Now this Bluezilla is already assembled. But that's what the other crane is going to look like. It's just bigger than that. Also 8, 9, and 10, and 2, and 3, and 4, and 1. So why did the nose land into the direction of the engines? Darknaze, I still can't figure that one out. Catastrophic energy release, I guess, would be the right way to say it. What are they putting the GSE tanks on? The GSE tanks are going on gigantic concrete foundations. This thing right here, see that? This is where the second one is being stacked on this one today. And then I'm not sure where the third one is going. See that? It's a huge concrete foundation. SpaceX is successful NASA HLS mock-up? Successful. It's a weird way to say that, but yeah. Yeah, they scrapped the Mastro because they figured out a better way to do it. How did they paint stainless steel? I don't know, Builder. It must be like a marine paint or something. I know stainless steel is a pain in the butt to paint. You can paint it, but it takes a lot of prep, a lot of time. That's right, James. Delivery pipes. Yeah, Falcon, they had a problem with one of the engines. They reinstalled it last night, but they need a couple of extra days. Something went a little wonky. I don't know what it is. Tubes! Dodge. Bird. Truck. Yeah, it's the internet truck. Well, like I said, it was a series of tubes, kind of like a big truck. I mean, there you go. I don't know what those are for, guys. I'm guessing that's something ground side. That doesn't look like any type of flight hardware. Yeah, maybe, Sevi. Those do look like AC ducts, yeah. And quite possibly even regular ducts. Huh. Huh. Huh? Does the U.S. still use Titan missiles? No. Not since 2005. Do you think Elon plays KSP? Yeah, he plays with his kids in LT from what I understand. He said that a bunch of times. Anyway. What'd you think? Pretty cool. Not too much space news today. That was actually a shorter space news, to be honest with you. Strong Gov, I think you're a blessing to the internet. That's what I think. Wow. Thanks, DCE. I appreciate that, man. Thank you. That other guy that left here because he's like, yeah, I'm leaving now. He clearly didn't think so, but... yeah. The last part was anchor points that got cemented in. Do they use solid missiles? Most of the ICBMs that the U.S. fields, no, all of them are solid based, yeah, for submarines and for ground side. SRBs are better. They can last, you could just keep them in their tube and they stay fine the entire time. Did you know they did a helicopter on Mars? Wait, what? Really? They did a helicopter on Mars. Coco update. Work on Octograbber 3 progresses in the front bay while the flash unit processes wastewater from the heat shield silica slurry process. The SIDCO facility is hopping up with demand for Starship TPS. Cool. That's going on over in Florida. Yeah, and once again, for the people that see it, they did helicopter on Mars. Yep, see? They did helicopter on Mars. Alright. So, that's going to do it for space news. I hope you guys enjoyed that segment. We're going to get into KSP. We have some rocket work to do. We have some rocket nositel work to do. How did the upgrade to Freedom 10 go? Everything seems to be okay, King. But we're about to put that to the test pretty much now. Dang, helicopters are everywhere. I know, right? Okay, so I'm going to load up KSP. Car news. Has Dynetics of the national team made statements about SpaceX getting picked? Nothing. No. Took me a while to recognize Tory Bruno without the cowboy hat. Yeah. Bro. I love Tory Bruno. That guy's the best. What do you want for car news? We could talk about Formula 1 if you want real quick while this is loading up, but I gotta go top off the coffee real quick. Speaking of KSP, have you ever tried to implement a MATLAB Simulink model into it? Negative. So, first bit of Formula 1 news, I guess, while Kerbal is loading up. Testing rocket upgrades today. So, first ever Miami GP is coming in 2022. By the way, there may not be a COTA race next year for F1. Formula One is heading back to Florida with the news that the brand new Miami GP will be joining the calendar in 2022. The race, set to be the first since 1959 in Florida, the Grand Prix raced at Sebring in 59, will be held on an exciting new layout at the Hard Rock Stadium complex in Miami Gardens, home to the Dolphins. Ew. The circuit itself will